Welcome to the untamed depths of time, where the earth reshapes itself, and life takes on forms both familiar and strange. Tonight, we journey into the Cenozoic Era, the age that followed the dinosaurs, stretching across more than 66 million years. It was an era of sweeping change, when the planet rose from the ashes of extinction and life carved out a new destiny. The Cenozoic is often called the Age of Mammals, but that title only hints at its complexity. In these vast spans of time, towering forests gave way to endless grasslands, oceans stirred with new giants, and strange creatures roamed the continents, some like ancestors of the animals we know today, others like shadows from dreams. It was an age of extremes, sudden ice ages, powerful tectonic shifts, and climates that could transform whole landscapes in the blink of a geologic eye. This was also the time when the story of humanity began, buried deep within the branching paths of evolution. But long before us, Earth's surface teemed with immense predators, delicate flyers, and creatures so bizarre they almost feel imaginary. So let your mind drift as we travel through ancient plains and primeval seas, walking beside beasts long vanished, yet never truly forgotten. In this calm exploration, we'll uncover how Earth grew into the world we now call home, shaped by fire, ice, and the unstoppable force of life itself. Close your eyes, relax, and allow the quiet rhythm of history to guide you. This is the story of the Cenozoic Era, an age of rebirth, resilience, and transformation. The sky did not clear all at once. After the asteroid's thunderous impact, dust and ash sailed aloft, wrapping the world in a dim, gray veil that turned daylight into endless dusk. Trees smoldered where they fell, their bark seared black, and rivers ran thick with soot and broken branches. In that heavy silence, broken only by the slow hiss of fires cooling, Earth held its breath. Life, bent and battered, waited in hidden refuges beneath the charred canopy and within murky ocean depths, bracing for a slow, delicate recovery. In the pale twilight, the smallest survivors stirred first. Shrew-like mammals, each no larger than a modern rat, emerged from burrows lined with leaf litter and ash. Guided by the faint warmth filtering through the haze, they scuttled across ground carpeted in soot, noses twitching for insects, awakened by heat, yet wary of the ghostly quiet. Birds that once soared above the giants now hopped among embers, pecking at larvae hiding beneath fallen logs. Even in the seas, tiny plankton bloomed again, their sun-driven photosynthesis breathing life into empty waters. Then came the ferns. Delicate yet resolute, they unfurled new fronds through thin layers of ash, claiming burned landscapes with a soft green blanket. In ancient rock layers, geologists find a fern spike, marking this moment a sudden flood of spores that thrived where nothing else could. These first pioneers anchored soil, captured nutrients from ash, and lent cover to other denizens emerging from the shadows. Their quiet conquest reminded life that even in devastation, the pulse of renewal began with simple, patient growth. As ferns spread, the earliest flowers whispered their return. Small angiosperms, plants with blossoms and seeds, nudged through the green carpet, offering fragile petals in return for tiny pollinators. Hard-working beetles, flies, and early bees discovered nectar where there had been none, forging partnerships that would shape forests for millions of years. Each bloom became a promise, a delicate handshake between plant and insect, signaling that Earth's long silence was finally giving way to song once more. Beneath fresh foliage, mammals began to diversify. Some grew nimble digits to climb soft trunks, their wary eyes tracking shifting shadows above. Others honed teeth for nuts and seeds left behind by budding shrubs. In this era of small wonders, survival favored versatility. Creatures that could burrow, climb, swim, and scavenge thrived where giants had fallen. Over countless generations, these unassuming forms laid the groundwork for the grand tapestries of life to come. each subtle adaptation a note in an evolving symphony. Meanwhile, the oceans whispered their own recovery. Surface waters warmed as sunlight pierced the residue-filled skies, and microscopic algae sparked tiny blooms that fed burgeoning food chains. In shallow seas, primitive whales' early cetaceans, still bound by thousands of fine hairs, tested the boundaries between land and water. Their ancestors, driven from river mouths by fresh currents, learned to navigate open waters, nudging flippered bodies toward futures that would one day span the globe. Across slow-moving continents, a map of the world itself was being redrawn. India drifted northward, the Atlantic widened, and land bridges formed, then disappeared beneath rising seas. Each shift reshaped currents, climates, and migration paths, teaching life to adapt not only to local changes, but to a planet in constant motion. In the hush after extinction, this restless dance of land and water set the rhythm for ecosystems to explore new possibilities. In that fragile dawn, Earth survivors proved that resilience often hides in small footprints and whispered breaths. The great silence of the late Cretaceous yielded to a patient murmur, a promise that life, even when nearly erased, contains the seeds of renewal. As clouds of ash finally cleared, and the first true dawn of the Cenozoic Era broke, the stage was set for forests to reweave themselves, for mammals and birds to raise their stories higher, and for oceans to cradle new waves of wonder. In the soft light of a forest reborn, the first mammals moved deliberately through understories once ruled by giants. At dawn's pale edge, small shrew-like creatures slipped between ferns, their whiskers brushing damp leaves as they hunted insects stirred by the warmth of a rising sun. These tiny forms carried within them the seeds of a vast experiment in adaptation. No longer merely survivors, they were pioneers exploring every niche left empty by the great reptiles passing. In the hush of that new world, mammalian life began a slow, persistent expansion across the tangled green, through shrubby clearings, along riverbanks, and even into early grassland glades. Within a few million years, the Paleocene gave way to the Eocene, and mammals were everywhere. Forest floors felt the gentle padding of early ungulates with multi-toed feet that tested soft ground, browsing on shoots and leaves. Somewhere overhead, arboreal primate relatives, small and alert, clambered among branches, their hands shaped for grasping, and their eyes tuned to patterns of light and shadow. In wetland margins, amphibious relatives of modern otters and beavers paddled through reeds, seeking crustaceans and soft bark. Their varied body plans reflected a simple principle. Wherever a resource existed, a mammal would learn to exploit it. The expansion of mammals into aquatic realms tells one remarkable tale. In shallow seas and estuaries, early cetaceans' ancient whales paddled with limbs still bearing digits. Their long, sinuous bodies undulated through warm waters, testing fish for flavor and fishbone for feeding habits. Over time, limbs morphed into flippers and tails grew into powerful flukes, opening a new kingdom of oceanic giants. Not far behind them, sea cows, ancestors of manatees, reclaimed coastal lagoons, grazing on seagrasses in gentle herds. From tiny land creatures came leviathans of the deep, a transformation that would echo through millions of years of oceanic history. On land, another group of mammals found their moment, the ancestors of today's horses, tapirs, and rhinoceroses. In the early Eocene, Hyracotherium, no larger than a modern fox, bounced lightly through forest glades, nibbling on tender leaves and fruits. Its feet bore small, spreading pads with short toes, perfect for soft ground. By the mid-Eocene, these parasitoctals had diversified. Some elongated their limbs for faster running, others thickened their bodies to browse tougher shrubs. Across continents, their footprints lengthened and their bones strengthened, heralding the first gallops across clearing floors. Meanwhile, early forms resembled slender deer-like creatures, favoring a mix of grazing and browsing. Their stomachs evolved chambers for fermenting tough foliage, a specialized gut to extract every morsel of nutrition from leaves and stems. As grasslands spread in later epochs, some artiodactyls embraced the open plains, developing teeth for slicing abrasive grasses and limbs built for long, steady movement. Pigs and peccaries pursued omnivorous diets in woodlands, while deer-like cervids sprang into being as forests opened into parklands. Carnivorous mammals also seized opportunities left by extinct theropods. In the Eocene, creodonts, an early order of meat-eaters, prowled undergrowth with bone-crushing jaws. Their relatives, the first true carnivoromorphs, refined more nimble forms. Small weasel-like hunters darted through fallen logs, and bear-like species ambled into fruiting groves, looking for rodents and carrion. As forests thinned, swift-footed hyaenodonts and amphicyonids, bear dogs, emerged, large predators that combined canine speed with ursine strength. Over time, these groups waned, giving way to the modern families of cats, dogs, and hyenas in the Miocene, each honing claws and canines into precision tools for hunting. Rodents and lagomorphs, the groups that include mice, squirrels, rabbits, and hares, demonstrate the brilliance of small size and rapid reproduction. From tiny water rat analogs in early Eocene wetlands to tree squirrels launching themselves between branches, these mammals mastered every corner of the landscape. Burrowing forms tunneled beneath prairies, buffering themselves against temperature extremes and predators. Their incisors grew constantly, ever sharpened by gnawing bark, seeds, and even soil. By the Oligocene, they had become the most numerous group of mammals, a testament to the evolutionary success of combining small form with high fecundity. Parallel to these triumphs, the primate lineage slowly evolved greater dexterity and curiosity. From grasping hands suited to vine-braided canopies to eyes capable of judging fruit ripeness and branch distance, early primates explored the vertical forest as never before. In the Eocene, they were small, squirrel-sized creatures. By the Oligocene, larger forms began to appear, ancestors of monkeys and apes. Their brains expanded, social groups formed, and the earliest rudiments of what we recognize as intelligence and cooperation began to take shape. In South America, isolation fostered unique radiations. Xenarthrans sloths, anteaters, and armadillos paved their own evolutionary paths, their skeletons reinforced for digging or supporting heavy bodies. Giant ground sloths would one day tower over humans. Early armadillos spread across savannas and forests with leathery armor. Specialized anteaters evolved slender snouts and long tongues to probe insect mounds. This isolated continent, separated from North America until the Pliocene, became a laboratory of mammalian innovation, forging odd yet successful designs that contrasted with those elsewhere. Australia, drifting northward, nurtured yet another caste of mammalian characters, monotremes and marsupials. Duck-billed platypuses paddled through clear streams, their beaks equipped with electroreceptors to locate prey in muddy waters. Marsupial ancestors hopped through forests, their pouches cradling young where placental mammals incubated theirs. Koala-like leaf-eaters, bandicoot burrowers, and thylacine predators, wolf-like marsupials, flourished in the absence of placental competition. The continent's isolation preserved these lineages in a puzzle of ecological roles that only began to shift when Australia connected to Asia in the Miocene. Global climates during the Eocene still favored warmth, allowing lush forests to extend toward the poles. But as the Oligocene ushered in cooler, drier conditions, mammals adapted again. Forest dwellers moved toward equatorial refuges or clustered around water sources. Grasslands emerged in mid-latitudes, prompting the spread of grazing specialists' early horses with high-crowned teeth, antelope-like artiodactyls, and browsing rhinoceros relatives that grazed on tough grasses with broad, grinding molars. Predators likewise followed suit, evolving longer legs for open country pursuit and sharper vision for spotting prey across savannas. In the Miocene, about 15 million years ago, mammalian diversity reached a new peak. The age of grasslands reshaped ecosystems worldwide. Herds of hoofed mammals, horses, deer, giraffes, and camels patterned the plains, driving predators to refine pack hunting techniques or stealth stalking. In Africa, the first true hominoid apes appeared, arboreal teachers of balance and brachiation, setting the stage for future human ancestors. Elephants evolved sturdier legs and tusks for uprooting trees in expanding woodlands. The skies teemed with bats of countless varieties, fruit bats, insect-eating microchiropterans murmuring in twilight caverns and beneath forest roofs. In North America and Eurasia, the collision of tectonic plates created mountain ranges and rain shadows. The Himalayas' rise altered monsoons. The Rockies changed Pacific storms. These climatic shifts carved pockets of rainforest, savanna, and steppe, each fostering specialized mammalian clades. In colder highlands, small, thick-furred species prospered. In lowlands, large herbivores dominated. The dynamic topography ensured constant choice among niches and fueled continued diversification. As the Pliocene dawned, around 5 million years ago, many modern groups had already emerged. Early hominins, upright walking primates appeared in Africa's Rift Valley. They carried tools and later fire, forging the unique path of human evolution. Mammoth and mastodon proboscideans clad themselves in thick fur for cooler climates. Saber-toothed cats honed elongated canines for taking down large prey. Beavers perfected dam building. Bats refined echolocation. And anteaters in South America used long tongues to harvest ants unseen. Each of these lineages told a story of survival in shifting conditions, of footprints following prey migrations, of burrows shielding against cold, of social bonds that protected against predators. By the Pleistocene, about 2 million years ago, Earth had cooled further and entered cycles of glacial advance and retreat. Mammals proved remarkably resilient. Some lineages specialized in cold tolerance. Woolly rhinoceroses and bison forged through Ice Age steppe. Lemmings and voles burrowed beneath insulating snow. Mountain goats scaled craggy peaks. Others retreated to refugia, areas spared by advancing ice, maintaining pockets of genetic diversity. Still others ventured into new territories, humans colonizing every continent except Antarctica, bringing new ecological pressures and forming symbiotic relationships with domestic species. Throughout these tens of millions of years, mammals demonstrated a singular capacity to explore, adapt, and thrive wherever niches appeared. From the faint footsteps of tiny Paleocene insectivores to the ground-shaking strides of Pleistocene mammoths, they filled landscapes once void of large, warm-blooded life. Their bones, found today in layers of rock and permafrost, record the history of a world transformed. They remind us that, in the silence after extinction, life not only finds a way, but often flourishes in ways unimaginable before. Even now, that legacy unfolds. Modern ecosystems bear the imprint of those ancient radiations. The deer grazing our clearings, the bats that patrol our nights, the whales singing beneath our oceans. The world of mammals rising after the dinosaurs shaped the planet in every corner, weaving a tapestry of form and function that continues to evolve. And as climates shift once more, mammals ever adaptable write new chapters in the book of life, carrying forward the indomitable spirit of exploration that first guided them into the dawn after the dinosaurs. The forest awoke in whispers. In the hush that followed the great twilight, tiny shoots pushed through ashen soil, seeking light filtered through drifting clouds of dust. The first green arrivals were not towering trunks, but slender fronds of ferns, their coiled tips uncurling like gentle breaths against a gray-scale ground. Underfoot, handfuls of spores had drifted in the breeze, tucked into pockets of moisture left by cooling rains. As each frond reached upward, it etched a promise into the earth that life, even in its most delicate forms, would reclaim what had been silenced. Within a few centuries, these pioneering ferns wove a soft carpet across vast landscapes. Their dense mats held ash in place and gathered fallen leaves, creating pockets of richer soil. In those nascent nurseries, the first true flowering plants' angiosperms made their entrance. Small and unassuming at first, their blossoms were barely wider than a thumbnail, yet they signaled a profound shift. Petals unfurled to reveal tiny nectaries, and early pollinators, beetles, and primitive bees danced among them, carrying pollen from bud to bud. With each successful pollination, a cluster of seeds expanded the forest's vocabulary, adding new shapes, scents, and strategies to its growing lexicon. Standing amid these early woodlands felt like entering a dream. Sunlight filtered through young canopies of broadleaf evergreens, magnolia cousins, early laurels, and nascent sycamores, casting rippled patterns across damp undergrowth. The air was perfumed with the subtle spices of newly evolved blossoms, hints of citrus and ginger floating where once only smoke had lingered. Mosses, grayed by ash but renewed in vigor, clung to fallen trunks, their tiny leaves hosting myriad microhabitats. Under a single log, one might find springtails flicking through damp chambers, centipedes stalking the dark, and fungal hyphae knitting nutrients into the wood's cold heart. These were not static forests, but living experiments in adaptation. Trees developed leaves with trip-tips, elongated points that shed excess water in torrential rains, preventing fungal rot on waxy surfaces. Others grew thicker cuticles to retain moisture as seasonal patterns began to shift. New root architectures explored deeper layers of soil, seeking water tables that rose and fell with evolving climates. Mycorrhizal networks threaded through the earth, linking the roots of different species in silent exchange, distributing minerals and water like a shared lifeline. Liana's woody vines appeared next, weaving their way skyward. With swollen root systems at ground level and flexible stems coiling around young trunks, they formed living highways linking the forest floor to the canopy. Their leaves brought light down into darker nooks, feeding understory creatures and offering pathways for arboreal mammals still small enough to navigate slender branches. By gripping and girdling, lianas also imposed checks on tree growth, ensuring that no single species could dominate the rising canopy. In swampy lowlands, palms rose in sheltered clusters, their feathery crowns marking ancient riverbeds winding through verdant plains. Beneath them, ferns and understory shrubs found refuge in the broad shade, while termites built mounds that punctuated the green expanse. These mounds, tall and conical, pumped air through underground galleries, regulating the nest's temperature and providing safe havens for myriad invertebrates. Their clay-rich walls slowly weathered into fertile pockets, offering germination sites for the next generation of trees. Climate in the early Cenozoic favored warmth and humidity. Polar regions, though dark for months at a time, escaped the chill of ice, and fossils of palms and crocodilians have been discovered near what is now the Arctic Circle. With no polar ice caps to sequester water, sea levels remained high, flooding continental shelves and creating vast shallow seas that moderated coastal climates. On these margins, mangrove-like trees tethered their roots in brackish water, stabilizing sediments and hosting nurseries for fish and crustaceans that fed migrating birds. Seasonality existed not in frost and snow, but in monsoons and trade winds. Summers brought torrential downpours that nourished the canopy. Drier months tested plants' drought tolerance. Many species responded with deciduous habits, shedding leaves during the driest periods to conserve moisture, then unfurling a new cloak of foliage when rains returned. Others remained evergreen, their roots plunged deep enough to tap reserves beyond the reach of drought. This evolutionary divergence shaped forest mosaics, patchworks of evergreen groves, seasonal woodlands, and wetland fringes that teemed with specialized life. As forests matured, vertical stratification became pronounced. The emergent layer soared above, where the tallest trees, predecessors of modern redwoods, and emergent mahoganies stretched toward open sky. Below them, the main canopy formed an unbroken dome, home to countless epiphytes, orchids anchored to branches, bromeliads cupping rainwater, air plants bathing in filtered light. Beneath the canopy, a diverse understory of shrubs, saplings, and ferns thrived in dim glow. And at ground level, seeds germinated in the leaf litter, waiting for canopy gaps caused by fallen giants to burst into sunlight and opportunity. In these shadows, early primate relatives, small, wide-eyed mammals, perfected their leaps from branch to branch. Their grasping hands and feet left telltale marks on fossilized bark, evidence of arboreal pathways that predated true monkeys by millions of years. Insects retreated into folded leaves, awaiting dusk when bat ancestors swirled above, their leathery wings tuned to the slightest rustle of prey. Meanwhile, below, crawling mammals tested nocturnal niches, blending whiskered faces into the underbrush as they hunted insects, seeds, and the occasional sapling root. Flowering plant diversity exploded in turn. Families that had lingered in the dinosaur, shadows, magnolias, laurels, willow-like forms, multiplied into myriad descendants. Legumes appeared, enriching soil with nitrogen fixed in root nodules, fueling further plant growth. The first grasses, though still minor players, colonized open patches where ferns and shrubs could not thrive, setting the stage for future grassland epics. Their narrow leaves and fibrous roots hinted at C4 photosynthesis' eventual rise. But for now, they persisted alongside ancestral C3 relatives, a subtle sign of things to come. Meanwhile, competition and cooperation shaped forest dynamics. Canopy openings produced by storm-toppled trees invited light-hungry pioneers, fast-growing willows and poplar-like trees that seeded readily, covering bare ground in a matter of years. Their quick lives gave way to the slower-growing, more shade-tolerant hardwoods that formed the mature forest. Symbiotic relationships flourished. Ants nested in hollow stalks, defending host plants against herbivores. Fungi transported water and nutrients in exchange for sugary exudates. Birds scattered seeds of fleshy fruits far from parent trees, mapping the forest like roaming gardeners. Over millions of years, these processes knit new ecosystems across continents. In North America, the first modern-style deciduous forests took root, dominated by early oaks and beeches whose leaves darkened with tannins to deter insect browsing. Their autumn sheds revealed glimpses of structural hollows and nutrient cycling that sculpted soil depth and texture. In Europe and Asia, mixed forests of conifers and broadleaf evergreens provided corridors for species migrations as continents drifted closer. In tropical realms, ever-wet rainforests spread uninterrupted, evolving an astonishing variety of life forms that remain unmatched today. The arrival of mammals like the tapir-like pantodonts and browsing upland ungulates introduced a new type of disturbance. Their grazing habits opened understory glades, allowing light to penetrate in irregular patterns. Wallows left by large herbivores became breeding grounds for algae and aquatic invertebrates, attracting amphibians and providing water sources in dry seasons. Forest edges frayed into complex ecotones, where species from interior and exterior habitats mingled, forming hotspots of biodiversity. As the Eocene gave way to the Oligocene, the planet cooled gradually. Even so, many forests maintained their luxuriance by shifting poleward or evolving frost-resistant traits. In temperate zones, trees added antifreeze compounds to sap. Buds formed tighter seals. Bark developed insulating layers. Vegetation belts moved, compressed by cooling trends and the march of tundra at high latitudes. Ferns receded into humid refuges. Conifers regained dominance in cooler uplands. Early oaks and maples diversified within the emerging temperate woodlands. By the Miocene, around 15 million years ago, The first savannas emerged, where rainfall became more seasonal. Open woodlands dotted by scattered trees replaced unbroken canopy in some regions. Fluttering leaves of early grasses rustled under browsers, like Girafoids' long-necked ungulates sipping foliage at heights unreachable to shorter herbivores. Predators adapted to this openness. Ambush tactics gave way to endurance running. Packs collaborated to isolate prey, and sensory adaptations sharpened distance vision and acute hearing. Throughout these transformations, the trees the silent sentinels bore witness. Rings in fossilized trunks record years of abundant rain and seasons of scarcity. Pollen grains entombed in amber reveal shifting plant communities. Leaf imprints in rock page like pages in a book, each shape and vein pattern telling a chapter of climate and competition. From the fern spikes of the Paleocene, through the great palm groves of the Eocene, to the first cool forests of the Oligocene and the mosaic woodlands of the Miocene, the story of the first forests of the New Age is one of resilience and reinvention. Today, when we step beneath a vast hardwood canopy or wander the tangled undergrowth of a tropical jungle, we walk upon layers of that ancient history. We feel the echo of ferns claiming burned earth, the shadow of palms nodding in subtropical bayous, the hum of mycorrhizal networks still whispering underground. Our modern forests carry the legacy of those earliest green awakenings, the subtle adaptations that allowed plants to exploit new climates, to form alliances with animals, and to sculpt the world's surface into the living tapestry we know. And as climates continue to shift, these lessons from the past remind us that forests are both fragile and formidable. They respond to change with patterns written in the slow language of growth, death, and renewal. In every leaf stretched toward sunlight, in every root probing for water, in every seed waiting patiently for its moment, we glimpse the first forests of the New Age forests born in the ashes of extinction, thriving through adaptation and ever evolving under the vast sky of time. The waves that once carried thunderous currents of dinosaur echoes now whispered a softer song, a lullaby of renewal sung in blue and green. In the immediate aftermath of the mass extinction, the world's oceans lay shrouded in murky stillness. Sunlight, dimmed by atmospheric soot, filtered weakly through surface waters. Phytoplankton blooms flickered sporadically, sparking brief pulses of life that rippled outward in fragile rings. Yet even in this tentative beginning, a blueprint for a new marine realm was being drawn. In those earliest Paleocene seas, survivors clustered where shelter and food remained. Mollusks ammonites that barely escaped total collapse faded, their shells more rare each layer down. But bivalves, soft-bodied clams and oysters, proved more resilient, burrowing into sediment and opening to feed on scant plankton. Gastropod snails of many shapes crept across the seafloor, grazing on microbial films. Early crustaceans, tiny cousins of modern shrimp, scuttled beneath rocks, laying eggs that would hatch into larvae drifting with the subdued currents. Every crevice became a refuge, every upwelling a promise of sustenance. Sharks, the ocean's ancient hunters, endured through stealth and speed. In the Paleocene, most shark lineages were modest in size, no great white silhouettes cruising the shallows. They patrolled quietly. Hexangiform sharks with 6 or 7 gill slits ghosted through twilight depths. Small mackerel sharks darted after fish schools, their teeth slender and pointed. But evolution unfurled rapidly. By the Eocene, conditions favored bolder designs. Warm seas and abundant prey supported the rise of Carcharochus chubutensis, a megalodon precursor. These giant sharks, some measuring over 10 meters, patrolled coastal shells like living predators from myth. Their serrated teeth, poised to slice through flesh and bone, littered beaches when carcasses washed ashore. In the fossil record, their massive jaws tell of apex dominion in a world still rediscovering its balance. Meanwhile, the slow but steady rebirth of coral reefs reshaped shallow marine landscapes. As water temperatures rose once more and acidity fell, coral polyps secreted calcium carbonate skeletons, building reefs that buzzed with new life. Fish, a dazzling array of early telliasts, took advantage of structural complexity. Blue-spotted wrasses flitted among finger-like branches. Early butterflyfish nibbled algae off staghorn corals. Tiny gobies guarded sandy burrows at reef edges. In deeper channels, solitary corals formed mini kingdoms, their meadows feeding currents of plankton and offering sanctuary to invertebrates. In open waters, bony fish exploded into hundreds of families. Tuna-like predators' early scombrids chased schools of lanternfish under moonlit waves. Billfish ancestors, slender and swift, tested their bills on squid and small fish, slicing through water with precision. Pelagic rays glided in silent formation, their wing-like bodies casting diamond shapes against the sun-dappled surface. Every niche, from the neon-lit twilight zone to the sunlit crest of the thermocline, teemed with evolving innovation. Amid this profusion of finned life, the first marine mammals began to emerge. Their lineage traced back to land-hoofed spirits that slipped into shallows, drawn by the promise of fish. Pachycetus, the walking whale of early Eocene rivers, bore slim limbs and a head half-finned in shape. Its ears, adapted for underwater hearing, marked the first beat in a symphony of cetacean transformation. Over the next 10 million years, protocetids like Ambulocetus learned to swim with undulating spines, paddling behind in a motion, part otter, part eel. Each pulse in the water guided a shift. Limbs shortened, tails lengthened, noses crept upward toward blowholes. By the late Eocene, Basilosaurus took shape in elongated form nearly 20 meters long, its tiny hind limbs a vestige of terrestrial ancestry. In its muscular fluked tail, one saw the promise of modern whales. Sirenians, relatives of manatees and dugongs, followed their own watery path. In warm, shallow bays, they nibbled seagrass meadows, their paddle-like forelimbs steering over beds of lush green. Their ancestors, land-dwelling ungulates, found in submerged pastures a refuge from terrestrial predators. Over generations, buoyancy replaced bone density, and tusks emerged in some species for scraping bark and navigating muddy bottoms. From tiny hires to heavy grazers nearly 4 meters long, early sea cows carved out a niche that endures along tropical coasts today. As the Eocene warmed toward its peak, equatorial waters grew almost tropical. Tropical and subtropical species extended ranges toward high latitudes, creating near-polar coral communities and temperate kelp forests in unforeseen places. Penguins, flightless seabirds born of alurid ancestors, swam into Antarctic seas, their flippers sculpted by cold currents. Early penguins, tall as humans and coated in dense plumage, dived in frigid waters for fish and squid, their buoyancy preserved by oil glands that coated feathers in sleek waterproofing. Seabirds like albatross ancestors took first wing over vast swells, their long, narrow wings spanning ocean miles as they followed upwelling fronts teeming with nutrients. Yet the ocean's stability was not eternal. At the Eocene-Oligocene boundary, Earth cooled. Antarctic glaciation began. Cooling currents carved new pathways. Upwelling zones off South America, Africa, and Australia grew richer, fueling nutrient cycles that favored plankton blooms. Bony fish adapted to cooler waters. Cod-like gadiforms replaced tropical shoals. Salmoniforms found niches in northern seas. New herring relatives shimmered in schools beneath rippling waves. Giant sharks declined in some regions as prey shifted and cooler temperatures slowed metabolic rates. Smaller, more efficient shark species like lamniforms rose to prominence, their lean bodies crafted for long-distance migration across chilly waters. Marine mammals, too, felt the chill. Many cetaceans moved toward modern echolocating tooth, whales, odontocetes, whos. Melon-shaped foreheads focused sonar clicks into the dark. Dolphins, porpoises, and sperm whales diversified in deep ocean trenches, using sound to find squid and fish under moonless skies. Baleen whales' mysticetes developed keratinous plates to filter feed on krill and tiny crustaceans, their massive throat grooves expanding like concertinas to engulf vast gulps of water. Blue holes, their tongues as large as elephants and their hearts as big as small cars, evolved within this dance of feast and famine. Their songs, transmitted for miles, wove a network of communication across basins. The rise of kelp forests and seagrass meadows in cooler seas created new refuges and feeding grounds. Sea otters in modern times, keystone species descended from mustelid ancestors that swam in nearshore Pacific waters. Their dense fur trapped air for insulation, and their smart paws smashed shellfish on rocks. By controlling sea urchin populations, they maintained kelp canopies that sheltered juvenile fish and sequestered carbon in coastal ecosystems. Over the Miocene and into the Pliocene, tectonic shifts continued to redraw ocean basins. The closure of the Tethys Sea reshaped currents between the Atlantic and Indian Oceans. The uplift of the Isthmus of Panama linked the Americas, altering hemispheric flow patterns. These changes triggered glacial cycles, drawing ice sheets at high latitudes and lowering sea levels by as much as 120 meters. Continental shelves emerged as dry land, pressing marine species into shrinking basins and forcing further adaptation. Mass migrations became common. Humpback whales followed plankton blooms from polar feeding grounds to tropical breeding waters, mapping ancient routes later sung by sailors. Leatherback turtles, relatives of early marine reptiles, tracked jellyfish blooms across oceans, their migrations spanning entire hemispheres. Giant deep-sea squid remained elusive, their soft bodies rarely fossilized, but known today from scars on sperm whale chests and tantalizing glimpses in remote submarine footage. Sharks, too, learned to move with purpose. Great whites patrolled coastal upwelling zones, their cold-blooded bodies adapted for long, cold swims. Hammerhead sharks followed temperature gradients where schools of stingrays rested, using unique head shapes to pin prey. Mako sharks zipped from equator to high latitudes in record time, their endothermic physiology supporting bursts of speed that earned them a place among ocean's swiftest predators. By the Pleistocene, the stage was set for a modern marine world. Sea levels rose and fell with each glacial advance, carving lagoons, estuaries, and reef platforms that nurtured diverse communities. Icebergs calved into oceans, stirring nutrient-rich waters and inviting whales to feast on krill concentrated in blooms around floating ice. Coastal humans, Homo sapiens, entered this world late in the story, bringing boats and nets, echo sounders, and trawlers, harnessing technologies to chase the ghosts of ancient patterns and sometimes disrupting the delicate balance. But even as human influence grew, the echoes of the ocean's transition remained. In every tooth of a fossil megalodon, we read the blueprint of apex predators, carved by Eocene abundance. In every early whale fossil, we trace the steps of terrestrial creatures learning liquid freedom. In every coral reef and kelp forest, we see the tenacity of life weaving new structures from soot-dark rubble. And in the silent wanderings of seabirds and migrations of cetaceans, we feel the pulse of a marine realm still shaped by those first post-dinosaur waves. As the vast blue world settled into rhythms both familiar and new, its story wove seamlessly into the tale of continents rising and climates shifting. While oceans teemed with evolving life-giant sharks, stranger whales, and every creature between the land quietly reassembled its own green tapestry. And so, the great narrative of Earth's recovery continued, each chapter flowing into the next, like a tide that never quite rests, pursuing renewal in every ebb and flow. The world's rhythms shifted again as the Cenozoic deepened, ushering in an era when the heirs of small, agile mammals grew into colossal behemoths. Across continents, forests and grasslands shaped by earlier warmth gave way to expanding savannas, steppes, and tundra belts. With climates oscillating between ice and interglacial warmth, abundant plant resources and seasonal communities created open niches ripe for giants. From the frozen plains of the mammoth steppe to the humid forests of South America, mammals that once slipped silently through undergrowth began to exceed human height-towering browsers and grazers that carried ecosystems on their broad backs. This was the age of giants, a time when life stretched the limits of body size in varying experiments of scale and survival. Pleistocene landscapes bore the imprint of repeated glacial advances. As ice sheets crept southward, sea levels fell, connecting land masses and allowing the great wanderers to roam. Grasslands flourished in newly exposed plains, producing vast stores of carbohydrate-rich grasses. Large herbivores found in these meadows a banquet that fueled astounding growth. Quantity of food translated into bulk of body. Mobility became key, and the capacity to traverse long distances in search of grazing grounds favored those with massive frames and powerful limbs. Predators learned to stalk these giants, long-distance hunters shadowing herds across frozen steppe. Together, predator and prey wove a saga of giants and the hunters they could not ignore. Bergmann's rule, the ecological principle that larger body sizes prevail in cooler climates, played out on a grand scale. Bulk conserves heat. The smaller the surface-to-volume ratio, the slower the loss of body warmth. In the Pleistocene's chill, Arctic and alpine regions became havens for megaherbivores whose sheer mass served as living insulation. Thick coats of fur, subcutaneous fat layers, and slow metabolisms allowed these creatures to survive long winters. Beyond thermoregulation, size deterred predators. An adult mammoth or rhinoceros presented a formidable challenge, limiting attacks to the sick, young, or dying. In evolving these traits, the Age of Giants demonstrated nature's tendency to favor the magnificent, even as conditions grew harsh. At the heart of this epic stood the mammoths, charismatic titans of cold plains. Descended from modest proboscideans that ventured into Eurasia during the Pliocene, these creatures perfected life on the steppe. Steppe mammoths, Mammuthus trogontheri, stood nearly 4 meters at the shoulder, their curved tusks sweeping mighty arcs through the air. By the late Pleistocene, the familiar woolly mammoth, Mammuthus primigenius, carried dense underfur beneath long guard hairs, a double coat that gleamed like frost in dawn light. Their massive heads supported dual lungs and large nasal passages, heating frigid air before reaching delicate tissues. Broad, ridged molars ground tough grasses, while tusks excavated permafrost soils to unearth buried roots and sedges. In herds spanning hundreds, mammoths shaped vegetation patterns, trampling paths and fertilizing soils with droppings that encouraged plant regrowth. Across the ancient ranges of Eurasia and North America, giant rhinoceroses once walked with less fanfare but equal grandeur. Paraceratherium, the largest land mammal, ever roamed Oligocene woodlands and river valleys more than 30 million years ago. But its memory inspired later Pleistocene giants like Elasmotherium, the Siberian unicorn. Standing nearly 2 meters at the shoulder and weighing up to 4 tons, Elasmotherium wielded a single broad horn above its forehead. Though hornless Paraceratherium eclipsed it in height, Elasmotherium adapted to open grasslands, grazing on tough grasses and roots. Thick, semi-erect hair likely covered its body, protecting it from wind and cold. Massive limbs ended in sturdy hooves that trod compacted soil, with the reassurance only a multi-ton animal knows. In these rhinoceroses, gigantism converged on both browsing and grazing strategies, underscoring the versatility of large bodies. Further south, South America nurtured its own giants, the ground sloths. Megatherium giant sloths nearly 6 meters long and weighing up to 4 tons scraped tough leaves from branches with curved claws the size of human arms. Their hind limbs, robust pillars, supported massive torsos as they reared upright to feed. Balancing on bony tail vertebrae, that acted as a tripod. Their stomachs, slow-fermenting chambers, digested cellulose-rich foliage over hours, extracting nourishment from coarse vegetation. Though slow by speed, their enormous size deterred predators. Only the cunning of early human hunters posed a real threat. In more forested regions, Mylodon and Paramylodon carved niches in wooded valleys. Their shorter limbs and broader claws adapted for digging into termite mounds and uprooting roots. Thus, giant sloths embodied an alternate path to megaherbivory stationary strength rather than fleet-footed mobility. Meanwhile, North America's wetlands gave rise to Castoroids, the giant beaver. Towering at nearly 2 meters in length and weighing up to 100 kilograms, these rodents transformed riparian zones. With ever-growing incisors and paddle-like tails, Castoroids felled trees larger than modern beavers dared to tackle. Dams and lodges built by these giants redirected water channels, creating flooded meadows that fed other megafauna. In their wake, wetland birds nested in new marshes and amphibians thrived in still waters. Their teeth left deep grooves in fossilized logs, testifying to a power unmatched among rodents. Here, gigantism served ecosystem engineering, demonstrating that size conferred not only defense, but the capacity to reshape habitats. Predators also achieved heroic scales. Short-faced bears, Arctodus simus, in North America, stood 2 meters at the shoulder, their jaws capable of delivering bone-crushing force. Their long, gracile limbs hinted at pursuit predation, a form of endurance running that challenged swifter prey across open grasslands. Saber-toothed cats, Smilodon fatalis, though more compact, carried curved canines nearly 20 centimeters long. Their robust forelimbs grappled prey, while powerful neck muscles delivered killing bites. These carnivores synchronized with herbivore giants, their numbers tempered by prey availability and climatic shifts. In South America, Thylacosmilus, the marsupial saber-tooth, evolved parallel solutions in isolation. Its saber teeth a striking example of convergent evolution among predators of prey, enormous and slow. Across the Australian continent, isolation nurtured giants of a different lineage. Diprotodon, the largest marsupial ever roamed Pleistocene woodlands, ungainly yet imposing. Weighing up to 3 tons and the size of rhinoceroses, these wombat-like herbivores fed on shrubs and grasses, their broad snouts stripping vegetation. Their young, carried in pouches, matured slowly, a life history trait that limited population growth but guaranteed the survival of each offspring. In the absence of placental elephants or rhinos, diprotodons filled similar niches, their fossils testifying to a land where megaherbivores took alternate evolutionary roads. Coexisting with giant kangaroos and giant monitor lizards, they formed part of a megafaunal mosaic unique to Gondwana's fragments. Though the age of giants conjures images of sturdiness and permanence, it was also an era of flux. Glacial cycles sculpted landscapes, expanding steppe environments, and contracting forests with each advance and retreat. Giants migrated along routes forged by low sea levels, crossing Bering Land bridges and exposed continental shelves. Populations adapted to shifting climates through changes in coat thickness, body mass, and migratory timing. Some lineages retreated to refugia Mediterranean woodlands, East African highlands, or Amazonian enclaves, where milder conditions preserved relict populations long after megafaunal extinctions elsewhere. The dynamic interplay between climate and geography wrote the biography of each giant species. Towards the close of the Pleistocene, human hunters emerged as a novel force. Clovis peoples in North America and analogous stone tool makers across Eurasia and Australia developed sophisticated weapons, atlatls, thrusting spears tipped with flint, and coordinated ambush tactics. Fossil sites reveal mammoth kill sites with thousands of bones arranged in butchery patterns, testament to sustained hunting pressure. Ground sloths show cut marks where humans carved flesh, and giant kangaroo bones near human hearths, indicate consumption of the largest of marsupials. As humans refined tools and social cooperation, megafauna faced their most lethal predator. Simultaneously, climatic warming at the end of the last glacial maximum fragmented habitats. Rapid retreats of ice sheets produced sudden shifts. Tundra replaced by boreal forest, grasslands swept by invading woodlands, wetlands dried by changing monsoons. Giants, specialized for particular feeding grounds and seasonal migrations, struggled to adapt. Reproductive rates, already slow in many large herbivores, failed to match increased mortality. Extinctions of mammoths, giant rhinos, and ground sloths occurred within a few millennia, a blink in geological time. Their absence reverberated through ecosystems. Plant communities changed in response to lost browsing pressure. Predator lineages collapsed without prey. Nutrient cycles slowed without massive droppings to fertilize soils. The age of giants offers both wonder and caution. These creatures, once stewards of Pleistocene worlds, carried the weight of ecosystems on their shoulders. Their extinction reminds us how swiftly human and climatic forces can unravel teetering balances. Yet in conserved pockets, African savannas, Siberian tundra, and Amazonian floodplains, modern elephants, rhinos, and tree sloths echo the ancient giants' roles. They shape vegetation, create waterholes, and disperse seeds on scales once only dreamt of by fossil records. Their continued survival hinges on protection, habitat connectivity, and respect for the evolutionary heritage they embody. In the footsteps of mammoths and Paraceratherium, conservationists search for ways to restore ecological functions lost with Pleistocene extinctions. Rewilding initiatives propose introducing proxy species elephants in Europe to mimic mammoth grazing, tapirs in the Americas to replace ground sloth seed dispersal. These bold experiments raise ethical and ecological questions, but their ambition reflects the age of giants' legacy. That size shaped landscapes in profound, irreplaceable ways. Restoring that dynamic could help stabilize modern ecosystems under climate stress. As we consider these titans of the past, we glimpse the frontiers of possibility. In every fossil tooth and bone, we find clues to edges of mammalian potential limits of growth, strategies for survival, and vulnerabilities in a changing world. Mammoths, giant rhinos, colossal sloths each once embodied the daring of scale and experimenting growth under the guiding hand of evolution. Their stories weave seamlessly into the broader narrative of life's resilience and fragility. From the first small mammals emerging from Mesozoic shadows to the final thundering herds of mammoths, the Cenozoic's tale is one of constant innovation. The age of giants marks a peak in that trajectory, an apex of body size, a symphony of ecological interactions, and a chapter closed too soon. Yet its echoes resound in modern conservation challenges and in our imagination of what nature can achieve. And beyond the giants themselves, life continues to evolve, finding new balances, new forms, and new scales in a planet ever restless beneath its slow-moving skies. In the next chapter, we will follow those changes. How giants gave way to modern communities, how grassland specialists rose in the wake of forest retreats, and how the legacy of mammoths and sloths still beats in the drumming hooves and lumbering strides of today as largest mammals. The story continues, carried forward by every creature, from the tiniest rodent to the grandest elephant, that shares the earth shaped by giants. The surface of our planet is never still. In the deep hush beneath drifting clouds, continents slide on currents of viscous rock, reshaping oceans, lifting mountain ranges, and rewriting the map of life. Imagine a world where landmasses once joined in a supercontinent called Pangaea, its shores touching both poles and its heart ringed by a vast inland sea. Over tens of millions of years, that single landmass cracked and fractured, sending fragments adrift like ice floes. As each piece sailed away, the oceans expanded, currents reoriented, and the stage was set for new climates, new habitats, and new paths for plants and animals to follow. When Pangaea began to split in the early Mesozoic, the Tethys Ocean opened between what would become Africa, India, Madagascar to the south and Europe-Asia to the north. That warm equatorial seaway brought tropical currents deep into continental interiors, allowing coral reefs to flourish in shallow lagoons. Along its margins, early mammals and dinosaurs thrived in lush coastal forests. But as Africa drifted northward, closing the Tethys behind it, ocean gateways narrowed. Currents that once circled freely now funneled through tighter straits, triggering changes in temperature and salinity. These shifts rippled outward, influencing rainfall patterns that fed inland river systems and the ecosystems they supported. Meanwhile, the Atlantic Ocean widened as North and South America peeled away from Europe and Africa. In the west, the Pacific Basin deepened as the Nazca Plate subducted beneath the Americas. These tectonic motions tilted continental shelves, altering the angles at which wind and waves struck coastlines. New upwelling zones formed off the western edges of continents, bringing nutrient-rich water to sunlit surfaces. Plankton blooms surged, feeding schools of fish that attracted marine mammals and seabirds. Where once the margins were muted, now they pulsed with life, shaping coastal savannas and wetlands that would become crucibles of convergence for terrestrial giants. As India hurtled north at locomotion speeds of several centimeters per year, it carved a path across the Indian Ocean waves, slapping new shores, tsunamis dressing volcanic islands in ash. Finally, 50 million years ago, it collided with Asia's southern edge. That impact buckled crustal plates skyward, giving birth to the Himalayan chain and the vast Tibetan Plateau. Elevations soared beyond 5 kilometers, splitting monsoonal winds and forcing heavy rains onto southern slopes while casting rain shadows across Central Asia. In the foothills, rhododendron forests cloaked steep valleys, creating refuges for species cut off by altitude. On the plateau's leeward side, grasslands spread, home to grazing herds that sparked evolutionary radiations in early ungulates and the predators that followed them. Simultaneously, tectonic collisions in Europe gave rise to the Alps' uplifted limestone and shale, now etched with glaciers. South America, no longer tethered to Africa, jutted westward into the Pacific, triggering the Andean orogeny. The Andes climbed in waves, creating rain shadows that sculpted the Atacama Desert and lush cloud forests on eastern flanks. High-elevation lakes filled crater basins fed by snowmelt, becoming isolated arenas for fish and amphibian speciation. Over time, plants adapted to thin air and intense UV, forging unique alliances with pollinators that buzzed at dawn when temperatures briefly rose. In the northern hemisphere, the collision of the Indian Plate with Eurasia redirected major river systems. What had once drained toward an open Tethys now reversed course, feeding inland basins. The Indus, Ganges, and Brahmaputra rivers carved deep gorges through rising mountains, transporting sediment loaded with nutrients deep into plains. These fertile deltas became hotspots of productivity. Crocodilians basked in sun-warmed waters. Birds nested in reed beds, and early hominins farmed grains in the floodplains. Landforms guided migrations. Wildebeest and gazelles followed northward corridors, while snow leopards shadowed them along cliffs. Elsewhere, Australia's long drift north isolated its marsupial inhabitants. Cut off from placental competitors, kangaroos and wombats radiated into every niche, from arid deserts to tropical rainforests. Wallabies bounded across eucalyptus woodlands. Koalas clung to high limbs to browse tender leaves. Tasmanian devils patrolled coastal heathlands as carnivorous sentinels. As the continent brushed the edge of the Southeast Asian plate, occasional land bridges allowed limited faunal exchange, enriching biodiversity. But for millions of years, Australia remained a laboratory of unique evolution, its marsupials unchallenged by eutherian mammals. Madagascar, torn free from India, carried with it lemurs arboreal primates, whose ancestors rafted across currents on gnats of vegetation. On the island's broken microclimates, from spiny bush in the south to mountaintop cloud forests, lemurs evolved into an array of forms. Sifakas bounding between trunks, bamboo specialists chewing slender stalks, giant extinct sloths dragging branches to their mouths. When humans arrived, these endemic giants faced extinction, but their fossil legacy speaks of an island shaped as much by drift as by survival. As continents repositioned, ocean currents responded in kind. The opening of the Drake Passage between South America and Antarctica enabled a circumpolar current that isolated Antarctica, chilling its coasts and allowing ice sheets to form. That transformation shifted global climate toward cooler, drier conditions, prompting grasslands and savannas to expand at the expense of forests. Herds of grazing mammals, horses, antelopes, and later bison and mammoths followed the growing grasses. Predators adapted, their teeth and limbs honed for the wide-open chase, while scavengers filled niches among bones scattered on the steppe. The closure of the Isthmus of Panama 3 million years ago linked North and South America, triggering the Great American Biotic Interchange. Armored glyptodonts and toxodonts trundled north. Horses and saber-toothed cats moved south. For 4 million years, exchange was uneven. Some clades thrived in new lands, others dwindled at the margins. But the land bridge reshaped mammalian evolution, creating novel ecosystems and reshuffling predator-prey dynamics in ways that reverberate today. Even smaller movements, rifting of microplates, uplift of volcanic arcs, drift of continental fragments molded habitats at local scales. Coastal subduction zones created archipelagos rich in endemic birds and reptiles. Rift valleys captured lake systems home to cichlid fish radiations. Basalt flows in oceanic hotspots formed isolated seamounts, each a stepping stone for planktonic larvae seeking new homes. Life leaped from rock to reef to rainforest, sculpted by shifting geometry beneath its feet. Throughout these eons of drift, ecosystems responded not simply to position, but to the resulting climates, soils, and hydrology. Mountain chains dictated wind and rain. Ocean currents carried heat to distant shores. Land bridges offered corridors of migration. In every case, moving land masses were not mere backdrops, but active authors of life's unfolding story. Species adapted by evolving new forms, forging new partnerships, or following shifting bands of habitability across the globe. Even today, the plates beneath us glide at rates of centimeters per year, a pace unnoticeable humanly, yet profound geologically. New rifts open in East Africa. The San Andreas Fault grinds past California. The Eurasian and Indian plates continue to collide, raising fresh peaks in Tibet. These motions foreshadow future continents. A supercontinent called Amasya drifting toward the Arctic, Africa closing the Mediterranean, Australia joining Asia permanently. Oceans will shrink and expand anew. Mountain chains will cradle new climates. Ecosystems will rise and fall in endless permutations of life's resilience. In the soft glow of morning light, the world's surface seems immutable. But beneath our feet, in the slow dance of continents, lies the dynamic engine that shapes every ocean current, every mountain stream, and every patch of green. As land continues its silent wander, the tapestry of life will reshape itself, each shift a prelude to fresh chapters of evolution. What tomorrow's continents bring, no single generation can predict, but the legacy of drift reminds us that life thrives on change, carving pathways through shifting ground toward ever-new horizons. And so the map of our planet past, present, and future remains a fluid canvas, unscripted yet full of promise, ever inviting the next generation of explorers to trace its stories in rock, water, and living breath. Soft morning light drapes the canopy in pale gold as the forest of the early Eocene stirs to life. Above, broadleaf evergreens hold dew like scattered jewels, and below, A hush of wings and whiskers whispers through fern-speckled clearings. In this gentle world still recovering from deep extinction, the ancestors of primates test the safety of branches and blazing sunbeams. Their stories begin not with thunderous footprints, but with the rustle of small creatures deep in shadows, inventing new ways to move, see, and probe. Imagine a mouse-sized mammal, its body sleek and its eyes round as beads, slipping through moss-rimmed corridors beneath giant trunks. Its hands, tipped with flattened nails instead of claws, explore bark and lichen with tactile precision. By daylight, it curls its tail to balance as it hops between lianas. By night, it curls in a nook of ferns, nostrils sifting the forest's hidden scents. This creature akin to the earliest plesioid epiforms carries the blueprint of what we call primate: grasping digits, forward-focused eyes, a brain alive with pattern and promise. These small beginnings can be traced to Paleocene dawns when sunlight first returned to a board of soot-dark skies. Mammals that once scurried in Mesozoic shadows seized new heights, literally venturing into trees spared from ground fires. In crumbling layers of rock, paleontologists find Purgatorius, a tiny ankle-boned pioneer whose flexible wrist hints at tree climbing. Its teeth sharp in simple snap at insects and seeds, a diet that underlines adaptability. With every careful step along a slender branch, it rehearsed behaviors that would echo through 60 million years. By the Middle Eocene, primates had diversified into two lineages: adapiforms, relatives of today's lemurs, and homomeids, the early tarsier-like leapers. In the dawn's stillness, Netharctus, an adapiform about the size of a modern squirrel, ambled beneath the canopy, plucking ripe fruits with gentle precision. Its grasping hands folded petals back. Its large eyes scanned for predators and prey alike. Nearby, Teilhardina, an homomeid no larger than your hand, sprinted along thin lianas, its long hind limbs coiling and springing in a dance of evolutionary excitement. Sunlight filtering through dense foliage sets patterns of shade and brilliance that these early primates learned to read. Binocular vision eyes positioned close together cast a single image of branch joints and dangling vines. Color vision, still in its infancy, begins to discern ripe fruit from unripe, young leaf from old. Smell, once the dominant sense of terrestrial rodents, yields to vision and touch. The forest becomes a three-dimensional puzzle: the right branch at the right moment, the right fruit at the right ripeness. Every successful leap strengthens instincts encoded by distant ancestors. As continents drifted and climates warmed, vast forests spread across North America, Europe, and Asia. In North America's Bridger Basin, fossil beds revealed 10 species of early primates living side by side, each carving a niche. Some favored flooded groves, paddling in knee-deep water for aquatic insects. Others clung to high canopies where palm-like trees crowned the sky. They ate fruits, leaves, insects, gum from tree wounds, and nectar hidden in deep blossoms. Their incisors split clusters of seeds. Their molars ground fibrous leaves, a sign of diets in flux. Crossing oceans, primates reached Africa by about 35 million years ago. In Egypt's Fayum Depression, the fossil-rich sands yield Egyptopithecus, a sturdy creature balancing between monkey-like and ape-like. About the size of a modern howler monkey, it possessed both opposable thumbs and a long tail. Its teeth suggested a diet of fruit and nuts. When it leapt between early Oligocene trees, it carried a legacy that would bloom into monkeys, apes, and much later, humans. South America's isolation fostered a separate primate tale. By around 30 million years ago, New World monkeys platyrrhines appeared in Amazonian fossil deposits. Somehow their ancestors rafted across the narrow Atlantic, perhaps on logs swept out from African coasts. They landed in a verdant land of ancient palms and strangler figs. There, they evolved into families still unique: spider monkeys with long, grasping tails, marmosets small enough to ride on flowering branches, capuchins whose clever hands taught cooperation and dexterity in ways that human eyes would one day recognize. Meanwhile, rising mountains reshaped habitats. The Himalayas, Andes, and Alps diverted rainfall and carved new climates. On the flanks of emerging ranges, primates adapted to cloud forests cool, mist-washed realms where moss draped every branch. Their fur grew thicker. Their bodies became larger to conserve heat. In South Asia's foothills, fossil lemur-like primates scurried through dew-laden moss, hinting at species that would one day fade, leaving only genetic echoes in Malagasy lemurs, thousands of miles west. By the Miocene, roughly 20 million years ago, apes, our closer kin, radiated through Africa and Eurasia. Proconsul in Africa, with its tailless form and upright torso, tested branch-supporting postures that prefigure later great apes. Across Europe and Asia, Dryopithecus clutched thin twigs, its fingertips sculpted for sensitive grip. Its teeth suggest a diet mixing fruit, leaves, and bark. The canopy shifted beneath its weight, and in those shifting woods, the path to humans narrowed from a multitude to a few profound lineages. Climatic cooling in the late Miocene contracted forests and expanded savannas. Where treetops had once met, open grasslands now stretched. Some primates adapted by descending to the ground. The first hominins, bipedal relatives of chimpanzees, arose in East African woodlands and savannas. Ardipashus ramidus, at 4 million years ago, walked upright but still climbed trees, a testament to its transitional life. Its hands could grip branches and wield simple tools. Its gaze began to scan horizons rather than forest floors. A shift in perspective, both literal and metaphorical. Australopithecines followed Lucy's Kindra group, dancing in dappled savanna light. They bore a blend of ape and human, curved fingers for tree grabbing, human-like toes for walking. Their grains, still small, nestled above chests capable of upright posture. In tool-making sites, flakes of stone lay in patterns of intention. Food processed at hearths in dark shelters hints at social bonds evolving around shared tasks and learned behaviors. Homo habilis, erect and curious, stepped across open plains bearing sharpened rocks. Its mind a little larger mapped new possibilities. Tool use no longer simply for subsistence, but for planning and creativity. Fire tamed night. Sharing meals taught empathy. As Homo erectus carried flame across continents, stepping into Asia's shadows and Europe's chill, humanity as first primate spark ignited a new kind of evolution, the shaping of culture and society alongside biology. Through all these millions of years, the primate story weaves a tapestry of small beginnings, tree-borne experiments, continental voyages, and social revolutions. From a mouse-sized climber in sootfall forests to humans charting lunar orbits, that story rests on milestones of grasp and gaze, of nest and network, of tool and thought. Each leap across a branch, each migration across a land bridge, each flick of a tail and clasp of a hand carries the weight of ancestors born under ancient canopies. Today, when we look into the eyes of a primate lemur, monkey, ape, we glimpse reflections of journeys both shared and divergent. Their futures, like ours, hinge on the habitats that once sheltered our first kin. As forests shrink and climates shift, the living echoes of that tree-bound experiment face challenges that test the same resilience that carried tiny mammals up into branches so long ago. The primate tale continues on a stage shaped by tectonic drift, climate flux, and human agency. In the soft glow of this evolving narrative, we sense that every moment is a step along a path that began in dawn's hush. The forest's gentle rustle, the inquisitive gaze of a young chimp, the leap of a gibbon between vines, all are alive with history. And as new chapters await in the interplay of culture, biology, and environment, we carry forward the legacy of that first primate spark, a legacy still unfolding in every cradle and canopy around the globe. Dawn's first light filters through misty wetlands as the world awakens to a new chorus, one of feathered life rediscovering the skies and reshaping ecosystems from pole to equator. In the centuries after the Cretaceous collapse, birds radiated into every vacant niche, some mastering the air with delicate grace, others abandoning flight altogether to dominate land and sea as towering, powerful runners. This is the story of how birds took to the skies and sometimes chose to stay earthbound, filling the Cenozoic with wings, struts, and songs that chart the rise of modern avian diversity. In the early Paleocene, survivors of the Great Extinction clung to small forest refuges and river corridors. Primitive birds, enantiornithines, and early relatives of modern waterfowl, pecked at insects and seeds among charred logs. But it was the lineages more closely allied to today's retites and waterbirds that found swift success. In swampy lowlands, long-legged ancestors of retites began to forsake flight as forest cover thinned in warming climates. Their wings no longer needed for escape shortened over generations, while legs grew strong and muscular, adapted for sprinting through marshes stalking fish and crustaceans. These first flightless giants, ancestors of moas, elephant birds, and the famed terror birds far to the south, ruled open plains with speed unmatched by contemporary predators. By the Eocene, terror birds Forus society had diversified into formidable forms, roaming South America's arid grasslands. Standing up to 3 meters tall, with skulls armed by hooked beaks a foot long, they hunted small mammals and reptiles in packs or as solitary stalkers. Their long strides, propelled by thighs as thick as a human thigh, broke into galloping sequences that echoed across sun-baked flats. In between cushioning steps, each silent footfall concealed razor-sharp claws built to grasp struggling prey. These birds became apex predators, filling the role of big cats and wolves, absent from the continents they patrolled. Their calls deep, booming honks carried across dry washes at dusk, heralding both territory claims and mating displays. As continents drifted and climates cooled toward the Oligocene, new habitats formed. In Africa's floodplains emerged the earliest ancestors of ostriches striding birds, whose broad toes spread weight across soft ground. Ostrich legs evolved for sprinting up to 70 kilometers per hour, their muscled thighs contracting and releasing like biological springs. When danger loomed, their wings once used for balance rather than flight opened as signaling flags, fanning brilliant white feathers against dark bodies. Courtship displays turned glades into arenas, where drummers of feather and foot announced fitness beneath a blazing sun. Meanwhile, the southern continents rehearsed parallel dramas. In Australia, emu ancestors grew tall against eucalyptus shadows, their lanky frames dappled by shifting light. On nearby islands, moa's giant retites endemic to New Zealand towered over ferns, browsing twigs and fronds with beaks that scraped bark. Their loss of flight saved energy, enabling them to reach weights of 250 kilograms and heights nearing 2 meters. In the hush of dawn, their ghostly silhouettes emerged from mist, silent as living sculptures, shaped by evolution to fill oversized browsing roles. While these land-bound giants ruled, the skies teemed with new families of flying birds. Early in the Paleogene, the first modern groups ducks, geese, and swans swanned through lakes and estuaries. Web-footed feet paddled beneath slender bodies. Serrated bills dabbed at aquatic plants. Over time, diving ducks honed plumage density for underwater pursuits, while grazers like the first swans ventured onto shore to crop grasses along riverbanks. Their migrations triggered by seasonal daylight changes, etched flyways that would later guide geese across entire hemispheres. Above forest canopies, passerines perching birds emerged as a transformative group. Their flexible toes gripped slender twigs. Their syringeal vocal organs perfected melodic repertoires. Early songbird calls filled dawn's hush. Trills, whistles, and warbles that carried through mist-laden valleys. With each new tune, forests found living soundtracks tailored to specific frequencies, enabling birds to communicate in dense foliage. Insect hunters, flycatchers, and warblers darted in dappled sunshine, capturing prey on wing with aerial splits that predated human aerobatics. From Africa's jungles to Asian foothills, these agile forms spread in a cascade of speciation events, culminating in the thousands of songbird species that dominate today. High above, raptors reigned. In the Oligocene, bones of fossil hawks and eagles appear in layers near ancient cliffs. Their talons, a sculptural blend of strength and curvature, clutched mammalian prey or fish plucked from river shallows. Some crafted nests of twigs and bones on wind-buffeted ledges, their young sheltered beneath broad wing covers until feathers glowed with adult modeling. Over millennia, vultures joined the sky scavengers whose keen sight traced carrion beneath circling turkey vultures in New World, environs and ancient gyps vultures in Old World realms. By gliding on thermal drafts, these birds economized energy, soaring for hours while surveying miles of landscape for fresh opportunities. In polar regions, unexpected avian chapters unfolded. Penguins, once land-bound swoopers of the southern oceans, began to trade air for ocean. Early spheniciforms retained rudimentary wings, flap-swimming through frigid Antarctic waters. Over time, their flippers flattened and stiffened, tails shortened into rudders. On ice-floored coasts, colonies of crested penguins chattered amid snowdrifts, rookery stones stacked beneath protective flipper-shaded nests. Their social bonds, demarcated by squawks and head-bobbing rituals, ensured that young chicks survived bitter storms, curling beneath brooding parents to share warmth beneath star-blanketed nights. Forested islands offered still more niches. In Hawaii, crows of the Corvus lineage became Corvus hawaiiensis the Hawaiian, black crow learning to break nuts with stones and use twigs to probe nests of land crabs. In New Zealand, the kakapo emerged, a flightless parrot whose moss-green plumage camouflaged it among rimu branches. Nocturnal and heavy-bodied, it evolved ground-scratching feet to forage for fallen seeds. Its inability to fly made it vulnerable, yet it thrived in predator-free forests until humans arrived. These island tales of crows, parrots, and rails underscore that birds of any lineage could lose flight and radiate in isolation, filling roles from pollinators to seed dispersers. By the Miocene, specialization created avian superstars. Bee-eaters nested in earthen banks, feeding on swarms of dragonflies. Hummingbirds, shimmering jewels of the Americas, fed on tubular flowers in co-evolved partnerships. Woodpeckers hammered trunks to extract grubs beneath bark with sinuous tongues. Shorebirds, sandpipers, and plovers mapped coastlines with long, probing bills, synchronized with tidal rhythms. Their migratory feats astonished, tiny bodies migrating thousands of kilometers at night, guided by stars, magnetic fields, and inherited compasses coded into fledgling instincts. Adaptive radiations continued into the Pliocene and Pleistocene. As ice ages advanced, many seabirds found refuge on offshore islands, evolving into flightless forms like the dodo in Mauritius and the great auk in the North Atlantic. These birds lost wing bones with each generation, but never needed them for escape. Wings shrank, muscles atrophied, energy redirected to reproductive success. On predator-free islands, gigantism again took hold. The stout, waddling great auk, its broad body weighing as much as 7 kilograms, fished shallow seas with powerful flippers. Its extinction centuries ago stands as a stark reminder that flightlessness, once a successful strategy, becomes fatal when new predators arrive. Even as some birds relinquished wings, others embraced new extremes of flight. Albatrosses perfected dynamic soaring, flinging themselves above waves with wingspans up to 4 meters. Petrels and shearwaters ventured into the Southern Ocean's fury, wings cutting wind like blades as they hunted squid under moonless skies. Swifts, the fastest of passerines, spent entire lifetimes on wing feeding, mating, sleeping while airborne. Their small bodies, like living kites, navigated updrafts along cliff faces where swallows once built nests. Through all these chapters, birds shaped and were shaped by changing climates, shifting continents, and evolving ecosystems. Their bones, found in sediment cores and cave deposits, tell stories of migration corridors now submerged, forest types now vanished, and predator-prey dances now frozen in time. Yet their legacy endures in every crow's caw at dawn, every osprey's plunge into clear water, every hummingbird's turquoise flash in flower light. And as the world warmed and cooled, as land bridges appeared and flooded, birds adapted again and again, trading flight for speed on foot, foraging at sea, or fine-tuning feathers for sonic songs. Their story is one of relentless reinvention, a testament to wings, to ground, and to the boundless sky that calls out for exploration. Here beneath the unfolding sun, their wings still beat patterns written over millions of years, carrying them into new dawns as the next chapter in Earth's grand narrative unfolds. A gray hush settles over a world in motionized sheets, creak across ancient shields. Deserts bloom beneath a roaring sun, and winds trace invisible arcs between warming seas and cooling poles. Earth's climate is never static. It breathes in deep cycles of warmth and chill, carving patterns in rock, shaping the rise of mountain ranges, and directing the ebb and flow of deserts. Over the last 60 million years, temperatures have swung like a slow pendulum. Greenhouse peaks gave way to icehouse lows. Forests retreated beneath advancing glaciers, and shifting rain belts painted dunes and oases across the continents. This is the story of changing climates, how ice ages marched across the world, deserts claimed new territory, and temperatures rose and fell in a rhythm as old as the planet itself. In the aftermath of the Paleocene-Eocene thermal maximum, an event when global temperatures leaped by 5 to 8 degrees Celsius over a few thousand years, Earth basked in a greenhouse glow. Palm trees grew near the poles. Crocodilians basked in Arctic estuaries. Rainforests draped over what would become Greenland. But warmth was not eternal. As volcanic carbon emissions waned and rock weathering drew carbon from the air, the planet cooled. By the end of the Eocene, roughly 34 million years ago, the first ice sheets formed on Antarctica. With each layer of glacial ice, the world's climate slid toward cooler, drier states, rewriting the scripts of forests and savannas and ushering in a new age of cryosphere and tundra. The Eocene-Oligocene transition marks the advent of a true icehouse world. Antarctica, once a realm of temperate forests, lay buried beneath kilometers of ice by 30 million years ago. The formation of the Antarctic Circumpolar Current, as continents drifted into position, isolated the southern continent and chilled its margins. Meanwhile, ocean circulation patterns shifted, triggering cooler waters in the northern Atlantic. Forests retracted from high latitudes, replaced by open woodlands and grasslands. Coastal upwelling zones grew richer, feeding marine plankton and altering the chain of life from the tiniest foraminifera to the ancestors of modern whales. As the planet tumbled into the Miocene, warming pulses appeared amid the icehouse descent. The middle Miocene climatic optimum, around 15 million years ago, saw a brief reversal. Temperatures crept upward by 2 to 3 degrees. Forests recolonized high latitudes, and crocodilian fossils surfaced in what is now Germany. Yet this interlude was but a pause. A renewed cooling trend followed, laying the groundwork for the Pliocene-Pleistocene ice ages. Mountains rose as continents collided. Himalaya and Andes thrust skyward, altering monsoon patterns and water cycling. Rain fell in new places. Deserts baked under shifting wind belts, and grasslands spread across mid-latitude plains. With the Pliocene's end, around 2.6 million years ago, Earth entered its most dramatic cold and warm alternation, the Pleistocene glacial cycles. For the next 2 million years, ice advanced and retreated across North America, Europe, and Asia in roughly 100,000-year rhythms shaped by subtle shifts in Earth's orbit. At glacial maxima, ice sheets overrode Canada and Scandinavia, lowering global sea levels by up to 120 meters. Continental shelves emerged as dry plains, corridors opened for migrating beasts and humans, and former reefs lay exposed under cold winds. Interglacial periods took the world back toward temperate climates. Forests crept north, grasslands hummed with life, and sea levels climbed to flood coastal realms. This seesaw of ice and warmth sculpted ecosystems at every scale. In glacial times, steppe tundra stretched from the Bering Land Bridge across Siberia into Europe, supporting megafaunal herds of mammoths and bison. Interglacial warmth invited temperate forests northward, creating refugia for temperate animals and isolating cold-adapted species on mountain islands. Rainfall belts shifted, and monsoons pulsed in and out of regions like the Sahara, which alternated between parched dune seas and grassy savannas dotted with lakes. The interplay of sea level change and climate cycles also shaped archipelagos. Islands expanded and merged, then fractured again, driving waves of species dispersal and isolation. Deserts themselves have a story of rise and fall woven through these climatic oscillations. The Sahara today is the world's largest hot desert, but during wet phases times, when summer monsoons pushed farther north, it bristled with lakes and grasslands. Fossil jaws of hippos and elephants lie in now barren river channels, testament to monsoon surges that once fed swamps teeming with crocodiles. When monsoons retreated, dunes marched into green valleys, burying settlements and graves beneath blinding sands. Similar dramas unfolded in Arabia, Australia's interior, and North America's Great Basin. Deserts grew during dry ice ages and shrank when warm rains returned, reshaping habitats in dramatic pulses. At the same time, high mountains wrote their own climatic chapters. The uplift of the Rockies and Himalaya tugged on atmospheric circulation, strengthening monsoons in Asia and rain shadows in Central Asia. The Tibetan Plateau, a vast, high-elevation expanse, acted as a heat engine, drawing moist air from the Indian Ocean and forcing it upward into monsoonal rains. When the plateau rose above a critical elevation, monsoons intensified, nourishing rice paddies and feeding rivers that carve some of the world's mightiest valleys. Yet uplift also created barriers. Westerly winds lost moisture, deepening deserts in Xinjiang and Gobi, while Andes uplift fostered Patagonia's cold deserts and Altiplano's salt flats. Ocean currents, too, shaped regional climates as continents drifted into their present positions. The closure of the Central American Seaway, as the Isthmus of Panama formed 3 million years ago, rerouted warm equatorial currents into the Gulf Stream. That mighty river of warm water began to deliver heat toward northern seas, modulating European climates and possibly fueling the waxing and waning of North Atlantic ice sheets. At the same time, the opening of the Drake Passage between South America and Antarctica allowed the west wind drift to encircle the southern continent, cooling Antarctic waters and reinforcing the ice sheets that define Earth's cold extremes. Throughout these changes, global temperatures trended downward from the warmth of the Miocene toward the cold of the late Pleistocene. Yet the fluctuations around that trend interstadials, abrupt warming events, and short-lived glacial pulses often prompted rapid ecological responses. Vegetation zones shifted tens of kilometers per century. Mammals migrated along advancing and retreating habitats, and human ancestors followed game herds into new lands. The interplay of ice, water, and heat sculpted the life worlds of early Homo species, influencing migration out of Africa and shaping the rhythms of hunter-gatherer societies. The Holocene dawned 12,000 years ago as the last ice sheets retreated for good. In a geological heartbeat, forests reoccupied northern Europe, grasslands spread across deglaciated plains, and reindeer herds gave way to moose and elk. Sea levels rose, drowning coastal shelves that supported. Paleolithic communities flooded, now beneath the North Sea and off Japan's Honshu coast. Global mean temperatures stabilized within a narrow band, and Holocene climatic optimums warmed some regions beyond today's conditions, fueling the emergence of agriculture in fertile river valleys. Yet even the Holocene held surprises. The 8.2 Ka event plunged northern hemisphere summers by several degrees in a matter of decades, possibly triggered by freshwater influx from melting lakes. Subtropical monsoons shifted, causing drought and societal stress in Mesopotamia, ancient Egypt, and the Indus Valley. Medieval warm periods and little ice ages followed, reshaping Norse settlements in Greenland and vineyards in Europe. These relatively modest fluctuations remind us that even small nudges in climate can ripple across societies and ecosystems. Today, as we face a new chapter of rapid warming driven by greenhouse gas emissions, the lessons of past climate shifts are more vital than ever. Ice ages remind us of Earth's sensitivity to changes in greenhouse gas levels and orbital geometry. Desert expansions teach how water-limited systems respond to temperature and circulation changes. Monsoonal patterns show how regional climates hinge on landform and ocean currents. By understanding ancient climate dances, we can better forecast the rhythms of our own warming world. In this tapestry of ice and heat, of shifting belts of rain and desert, life has shown a remarkable capacity to adapt, migrate, and radiate. Every forest that reclaimed tundra, every species that followed monsoon rains northward, and every bird that crossed emerging land bridges stands as testimony to resilience in a changing world. As the climate story continues to unfold, the next chapters will be written not only in tree rings and ice cores, but in the actions we take to steward our fragile home one, still breathing in cycles older than humanity itself. Life on the plains awakened to a new pulse when the forests at the world's mid-latitudes began to yield canopy to endless seas of grass. As global temperatures cooled and seasonal rainfall patterns sharpened in the Miocene, sturdy clumps of C3 grasses gave way to vast expanses of C4 species, shorter roots, but tough, fibrous blades that thrived under bright sun and fickle water. In the soft glow of early mornings, these grasses shimmered like waves on green oceans, carpeting hills and floodplains in a living mosaic that stretched as far as the eye could see. This transformation didn't just redraw the map. It rewrote the rules of survival for every creature that grazed, hunted, burrowed, or soared above these open realms. Beneath the clear horizon, the first true grass specialists emerged. Tiny ancestors of modern horses, once the size of foxes, honed their teeth to slice blades with precision, replacing leaf-mashing molars with high-crowned teeth that could endure silica-rich wear. With each meal of grass, their grinders grew taller, their digestive tracts lengthened, and their limbs became longer and leaner. By the late Miocene, these early equids had evolved single-toed hooves, spring-loaded tendons, and flexible spines, enabling them to flee swiftly across shifting herds of grass. In the distance, their silhouettes bobbed as they grazed in open savannas, heads nodding rhythmically against a background of wind-stirred grass. Parallel revolutions reshaped the hooved mammals of Africa and Eurasia. Artiodactyls, ancestors of deer, antelopes, and bovids, developed multi-chambered stomachs that fermented coarse grass in microbial vats. Their splayed toes consolidated into sturdy cloven hooves, offering both traction in wet grasses and support on hard expanses. Pronghorn ancestors in North America responded with astonishing leg speed, their limbs evolving for endurance sprinting and respiratory efficiency. By contrast, Eurasian giraffoids stretched necks high above competing browsers, sampling foliage on scattered acacias at the margins of grassland. As grasslands expanded, the very soil changed beneath hoof and hide. Grass roots formed dense mats that held moisture and built thick organic layers, encouraging earthworms and termites whose tunnels aerated the ground. Surface water pooled in hollows, spawning ephemeral lakes and attracting herds of herbivores each dry season. Invertebrates, grasshoppers, locusts, dung beetles multiplied in booming numbers, forming vital links in emerging food chains. Birds learned to feed in these new niches. Plovers and lapwings dashed across short grass for insects, while bustards and secretary birds strode like avian sentinels, picking snakes and rodents from blades. Predators evolved in tandem. Long-legged saber-toothed cats crouched low in grass shadows, their shoulder musculature retooled for ambush rather than climb. Cheetah ancestors fine-tuned cardiovascular systems for velocity, their long spines and flexible pelvises flexing in mid-stride, propelling them to speeds unmatched by any other land mammal. Pack-hunting canids, the ancestors of wolves and African painted dogs, coordinated drives across open plains, flanking prey in collapsible formations. Vultures and hyenas patrolled the scoured bones of carcasses, their acute vision clocking the slightest flicker against a horizon of gold grass. Birds of prey claimed the skies above these expanses. Eagles bred atop rocky outcrops, scanning acres of grazing herds for vulnerable young. Falcons dipped into high-speed stoops, talons aimed like flying grappling hooks. Corvids, crows, and ravens expanded social intelligence, scavenging from predator kills and even cooperating with human hunter-gatherers whose fire-lit caves offered both food scraps and warmth. Insects became the scaffolding of flight. Dragonflies darted above reed-lined edges. Bee-eaters hunted insect swarms against the backdrop of rust-tinged clay pans. Seasonality defined life on these plains. Wet seasons coated the grass in succulent green, drawing herds of browsers and grazers to follow rainfall pulses. Dry months browned the meadows, concentrating animals around dwindling waterholes. Risk rose in these months. Predators lurked at drink sites. Competition for resources intensified. Many ungulates learned long migrations. Wildebeest routes in East Africa stretched hundreds of kilometers between Serengeti calving grounds and Masai Mara pastures. Their hooves carved permanent game trails that channeled seasonal flows of life, shaping grassland topography as reliably as any river. Smaller mammals found niches in tussocks and burrows. Ground squirrels and prairie dogs excavated elaborate tunnel systems, their burrow mounds creating islands of aerated soil that benefited root growth. Rabbits and hares mastered rapid multiplication, evading predators through reproduction more than speed. Rodents like kangaroo rats in North American deserts developed kidneys that concentrated urine, surviving on minimal water, a predaptation that later led grasslands into semi-arid scrublands. Long before human herds appeared, early hominins found refuge in grassland edges. Australopithecines roamed savanna mosaics in search of tubers and tuberous roots uncovered by the bristlegrass. Their feet carried them across boulder-strewn riverbeds and undulating grass hills, their hands adapting for tool use. Oldowan sites in East Africa bear the earliest stone flakes, evidence that meat-eating scavenged from predator kills supplemented plant diets. As stone chipped under the sun, future Homo species learned to exploit grassland resources with cooking fires and coordinated hunts. The open plains became classrooms for human ingenuity, where the lessons of mobility and cooperation reshaped our own evolutionary path. Grasslands influenced plant evolution in return. Firegrasses species that tolerated and even benefited from periodic burn spread in landscapes lit by natural fires ignited by lightning. Their heat-resistant seeds germinated in charred soil, creating flushes of new growth for grazers. Fire-adapted shrubs held flames low, protecting tree seedlings whose root systems would mature before competing grasses reclaimed the ground. This interplay of flame and growth created pyrophytic cycles, proving that grasslands were dynamic, ever-shifting ecosystems rather than simple, static plains. In cooler climates, steppe and prairie realms echoed similar patterns. Mammalian diversity blossomed in Eurasian steppe. Saiga antelope evolved bulbous nostrils to warm, icy air. Marmots learned hibernation in deep burrows. Wooded savannas at mid-latitudes hosted mixed feeders. Bison grazed short grasses in winter and browsed shrubs in summer. Human pastoralists Yamnaya and later Bronze Age herders rode horses across steppe corridors, managing herds of cattle, sheep, and goats in transhumance cycles dictated by grass growth. Domestication transformed wild grasslands into pastoral empires, altering biodiversity and dispersing species across continents. By the Holocene, the spread of agriculture and grazing intensified grassland extents. Wheat and barley replaced native grasses in the Fertile Crescent. Rice terraced floodplains in Asia. Maize fields spread across the Americas. Grazing livestock, cattle, sheep, goats trampled soils, promoted weedy grasses, and expanded grass-dominated landscapes beyond their natural boundaries. Megafaunal analogs vanished in many regions, replaced by domestic proxies that shaped both ecology and human culture. Yet the wild heart of grasslands persists in protected savannas and prairies. Bison herds roam Yellowstone, their hooves sculpting meadows and their wallows creating ephemeral wetlands. African parks preserve wildebeest migrations that echo Pleistocene rhythms. Australian grasslands still shelter kangaroos and wallabies in the hush of dawn. In these living landscapes, the legacy of ancient grassland expansions remains tangible, an interplay of plant, animal, fire, water, and human. Life on the plains illustrates a broader truth, that open, treeless spaces are as complex and vibrant as any forest. Grass may seem simple, but its biology and interplay of silica content, fire tolerance, and rapid growth drove evolutionary revolutions. The creatures that learn to eat, evade, and thrive in these sunlit fields wrote new chapters in the story of life's resilience. And as human activity now reshapes these plains, once more that history offers both caution and inspiration. Grasslands can recover if managed wisely. Communities and keystone species can rebound, and the intricate dance between herbivore and blade can continue on a world increasingly hungry for balance. Forever rolling beneath wide skies, grasslands remain arenas of motion, where every blade tells a story of adaptation, every hoofbeat echoes ancient migrations, and every season renews the timeless cycle of birth, growth, and rebirth. A low mist clings to the twilight grass as two figures emerge from opposite sides of an ancient clearing. One is low-slown and stocky, shoulders hunched beneath a tawny pelt, streaked with ghostly stripes. A matured-on saber-toothed cat, its curved canines glinting beneath slack lips. The other stands tall and gaunt, its long legs ending in taloned claws. A skeletal head crowned by a hooked beak, the ghost of a terror bird stalking the undergrowth. Both hunters pause at the edge of rustling grasses, nostrils flaring to catch the scent of unseen prey. In that moment, we glimpse the fierce diversity of Cenozoic predators, each a masterpiece of evolution, shaped by shifting climates, continents in motion, and prey that learn to flee and fight in turn. When the first mammals emerged from the Mesozoic shadows, predation was a deadly game of stealth and speed played among creatures no larger than rats. But by the early Eocene, as forests thickened and mammalian herbivores grew in size and variety, new lines of meat-eaters carved niches of their own. In Asia and Europe, creodonts, ancient carnivores with dagger-like molars, powled underbrush like living tufts of shadow. They lacked the sleek grace of later cats, but their bone-crushing jaws and stout limbs let them tackle armored prey. In North America, hyenodonts' hyena teeth showed a parallel path. Massive skulls armed with slicing carnassials, bodies built for a bite that could pulverize bone. Their reign lasted tens of millions of years, until competition for more agile carnivorans edged them toward extinction in the Oligocene. Into the mid-Miocene, true members of the order Carnivora took center stage. Primitive bear, dogs, and phisionids combined bear-like bulk with canine speed. Their long limbs and powerful shoulders let them run down hoofed victims in open woodlands. Across the globe, diminutive mustelids' early weasel relatives learned to hunt in burrows and rocky crevices, honing the stealth and ferocity still characteristic of their descendants. Vivarids, the forebears of civets and genets, padded through tropical undergrowth with plantigrade paws, sniffing out small mammals and reptiles. In Africa's early savannas, new predator guilds assembled. The nimravids, often called cat-like but no true felids, evolved saber-like teeth in compact skulls. Their ambush style matched that of later Smilodon, a pounce from low cover, followed by shearing canines aimed at the throat. In Europe and Asia, Arborifelids, another saber-toothed clan, reached massive sizes, their reinforced neck muscles bracing blows that could fell prey far larger than themselves. Multiple evolutionary experiments in saber teeth point to the irresistible advantage of the killing bite when prey grew heavy and cumbersome. By the Pliocene, the most iconic saber tooth of all took form in the Americas. Smilodon fatally stocky, with limbs built for grappling rather than running patrolled Pleistocene forests where mammoths and bison roamed. Its upper canines stretched nearly a foot long, sheathed within a powerful, broad muzzle. Killing required precision. Latch onto a quarry's flank, lock down with massive forelimbs, and drive the fangs into soft throat or belly. Smilodon's bulk made it vulnerable in open plains, so social hunting cooperation among siblings or groups likely compensated for limited speed. Fossil bone beds bearing dozens of individuals suggest pride like packs or family cohorts, returning year after year to rich hunting grounds. On South America's isolated landscapes, marsupial predators thrived in parallel. Thylacosmialis, a borhyanid true saber-toothed marsupial, stalked pampas and gallery forests. Its flanged lower jaw acted as a protective sheath for lethal canines, and its forward-facing eyes granted depth perception for night stalking. In the absence of placental competitors, these marsupials evolved dentitions that rivaled any mammalian carnivore, proving that when ecosystems are open, evolution finds repeating solutions to the challenge of slaying large prey. But not all dominant hunters carried fur. In the Paleogene wetlands of North America, an early line of crocodilians, Griposochus and Purosaurus ancestors, grew to lengths exceeding 10 meters. Their broad, at snouts bristled with teeth for crushing fish and small mammals venturing too close to water's edge. As forests retreated from rivers during the Miocene, giant freshwater crocs claimed islands of flooded valleys, ambushing deer and capybaras at stream banks. Meanwhile, in South America, the terror birds matured into apex predators. Phorusrhacids, some over 3 meters tall, evolved massive skulls and stiff neck bones. Their long legs ended in feet armed with sickle-like claws, able to tear flesh or pin prey. They ran in bursts of up to 50 kilometers per hour, terrifying contemporaneous mammals unprepared for bird-like ferocity. On ancient pampas, they preyed on notungulates, armadillos, and any unwary rodent that strayed into open grass. Their dominance ended only when North American mammals cats, bears, and canine hunters invaded via the Panamanian land bridge. In African savannas, lions, leopards, and hyenas emerged as specialist predators. Panthera leo walked onto the stage in the Pleistocene as open country grasslands matured. Their social hunting allowed them to bring down wildebeest, zebras, and buffalo herds far more efficiently than solitary stalkers. Spotted hyenas, no mere scavengers, developed bone-crushing jaws that left characteristic pits and splintered long bones at their dens. Their cackling calls echoed after sunset, announcing feasting gatherings that could rival the boldest lion prides. Hyenas and lions coexisted in a delicate dance. In cooler climates, the cave lion Panthera spelea prowled Europe, Siberia, and North America's ice-age tundra. Their thicker fur and larger paws adapted them to snowfields, preying on mammoths, bison, and even young mammoth calves. They likely worked cooperatively, slashing at prey to weaken them before delivering a suffocating bite to the throat. Cave lion dens, seldom in caves, but often beneath rocky ledges, harbor thousands of bones, fragments of a long-vanished chapter in predator-prey dynamics. Closer to the poles, the origin of polar bears marks another predatory shift. Descending from brown bears near the Pleistocene's coldest extremes, Ursus maritimus took to the sea ice, hunting seals at breathing holes. Their white coats shrouded them against drifting floes. Their massive paws distributed weight on thin ice. Their fat-rich livers fueled survival through lean seasons. In their turn, they remind us that predation is not only about strength in numbers, but about mastering new realms from grass to ice. Birds of prey also refined the hunter's art. The Haast's eagle of New Zealand, with a wingspan up to 3 meters, hunted moa and other flightless birds with talons like bear claws. On Tasmania's cliffs, the giant Haast-style eagle soared down at speeds exceeding 100 kilometers per hour, striking with lethal force. When humans arrived, overhunting of moa destroyed the eagle's food source, leading to its extinction, a sobering echo of human impact on apex predators. In ocean depths, apex predators evolved along separate lines. Megalodon Cartrocles megalodon became the largest shark ever known, reaching lengths of 18 meters. Its serrated teeth, perfect for slicing through blubber and bone, litter seafloor deposits where whales once dwelled. Later, great white sharks and killer whales replaced them, evolving pack hunting and complex communication to take down seals, dolphins, and even baleen whales. These ocean hunters remind us that predation spans every realm from forest floor to open sea. Across all these chapters, one theme recurs: predator and prey locked into an endless evolutionary arms race. When herbivores grew larger, predators added muscle and sharper teeth. When prey learned to flee in herds, ambush tactics and cooperative hunting gained an edge. When forests closed in or deserts spread, claws and hooves adapted to new terrains, snow, sand, swamps. In every case, ecological opportunities spurred morphological innovation. Saber teeth, flanged jaws, pack strategies, camouflage coats. The Cenozoic's predators refined the art of killing in every habitat Earth offered. Yet predation also shaped ecosystems in ways more subtle than mere numbers. Carcasses left behind fertilized soils and nourished scavengers, from vultures to beetles. Predators controlled herbivore populations, preventing overgrazing and ensuring plant communities remained diverse. The echo of a wolf's howl or an eagle's cry sparked learning in prey, vigilance, grouping, alarm calls. In many landscapes, predators forged the balance that makes grasslands green and forests lush. By the end of the Pleistocene, many of these great hunters faced decline. Climate shifts and human expansion drove saber-toothed cats, giant bears, terror birds, and mammoth specialist predators into extinction. Their absence left echoes in ecosystems now altered to favor smaller or more adaptable predators: foxes, coyotes, jackals, and human hunters, with technology far surpassing any fang or claw. Yet their fossil legacies endure in museums and rock beds, reminding us that the chapter of Cenozoic predators was once written in teeth and talons, in the thundering chase across plains and the silent stalk beneath night's cloak. As grasslands and forests continue to change around us, as deserts encroach with warming climates, we carry forward the knowledge that apex predators are vital threads in nature's web. Their loss can unravel delicate balances. Their presence can sustain the rhythms of life across continents. In the next section, we will explore how shifting climates, ice ages, monsoon cycles, and warming pulses reshaped not only predators, but all of Earth's living tapestry, forging new chapters of adaptation and survival beneath ever-changing skies. A hush fell upon the world, as if the very breath of the earth froze in place. From the polar caps southward, ice began its silent advance, sculpting continents into new shapes with slow but irresistible force. Towering walls of glacier poured down mountain valleys, their blue-white fronts grinding rock to dust and pushing moraines before them. Rivers swelled with meltwater, carving far-flung deltas and filling basins to bursting. In these landscapes locked under ice, life had to learn new rhythms of cold and scarcity, or disappear beneath the grinding weight of the Ice Age. As temperatures dipped across millennia, massive ice sheets took form in eastern Siberia and northern Canada. The Laurentide ice sheet spread 1,000 kilometers from its Canadian cradle, overriding forests and tundra alike. In Europe, the Fennoscandian ice sheet glazed Scandinavia in a mile of ice, pushing southward into Germany and Poland. Between these frozen giants lay narrow corridors of unglaciated refuge, cryptic refugia, where small pockets of forest and meadow held stubborn survivors. There, wolves and deer found shelter. Mosses clung to rocky outcrops. Humans paused in cave mouths, their breath steaming in the frigid air. At the margins of these glaciers, the world transformed into the mammoth steppe, a vast expanse of grass and shrub stretching from Spain's Cantabrian foothills across Siberia to Alaska. Beneath a thin layer of lowest wind-blown silt deposited in glacial winds, tussocks of sedge and grass thrived under the cold sun. This hardy vegetation sustained herds of grazing megafauna. Woolly rhinoceros with shaggy coats, steppe bison and massive lumps of muscle, and wild horses whose shorter limbs and thick manes shielded them from frost. In the dim light of the Pleistocene, this frozen prairie pulsed with life far beyond what one might expect of an ice-ridden world. The woolly mammoth was perhaps the most iconic beast of this realm. Standing nearly 4 meters tall at the shoulder, its shoulder hump laden with fat, it moved in herds across the steppe. Long, curved tusks, perfect for sweeping snow aside, in search of buried grasses arched in silent majesty as matriarchs led their families to winter feeding grounds. Beneath coarse guard hairs, a dense undercoat held body heat. A layer of subcutaneous fat insulated against the cold. Specialized blood vessels in its ears minimized heat loss, and its trunk, warmed by exhaled air, served as both a breathing tube and a tool for grasping shrubs. In countless generations, mammoths evolved a suite of adaptations attuned to the Ice Age's rigors. Yet survival in this gleaming domain required more than thick fur and fat reserves. Animals followed seasonal patterns etched into the land by glacial cycles. Spring meltwater nourished fresh shoots, and hungry herds moved in tandem with the thaw line. Autumn's first frost signaled the time to bulk up on roots and bark, storing energy for the lean months ahead. Herds broke into subgroups to winter in sheltered valleys, where wind-blown snow accumulated in drifts, providing deeper insulation. Many species, like the reindeer's ancestor Reinjeffer tarandus, migrated hundreds of kilometers each year, weaving predictable patterns across glaciers' margins and ice-dammed lake basins. For the predators of the Ice Age, the steppe offered both opportunity and challenge. Cave lions Panthera spelaea prowled the frozen plains in small prides, their stocky bodies and shaggy coats a match for the bitter cold. They hunted steppe bison and young mammoths by ambushing at kill sites, using sharp canines to deliver killing bites. Saber-toothed cats Smilodon showed a different tactic: shorter, sturdier limbs for grappling large prey and incisors designed to deliver precise throat slashes. Packs of dire wolves coordinated to harry herds toward waiting ambushes, while scavengers like hyenas Pachycocuta cracked bones with brute force to extract marrow. Even the skies teemed with hunters. Snowy owls glided across ice fields to snatch lemmings from burrows, while bald eagles circled meltwater pools for fish and carrion. Human hunters entered this world as both predator and prey. As Homo sapiens spread into Europe around 45,000 years ago, they encountered Neanderthals, adapted to similar conditions with broad noses for warming air and robust bodies to retain heat. Both hominin species fashioned specialized toolkits: flint blades for butchering, bone scrapers for hides, and spear points barbed for piercing thick hides of mammoths and bison. Hearths and cave entrances glowed through frigid nights, their firelight repelling cold and predators alike. Clothing stitched from hides and furs, combined with hide tents and windbreaks of bone and turf, created mobile camps that mirrored the rhythms of migrating herds. Yet the cold was relentless. During the last glacial maximum, around 21,000 years ago, ice sheets swelled to their greatest extent. Sea levels fell by over 120 meters, revealing land bridges such as Beringia between Siberia and Alaska. Here, ancient megafauna crossed into North America, carrying ecosystem dynamics into uncharted territories. Woolly mammoths ventured onto the newly exposed plains, while humans followed, giving rise to the earliest American cultures. In Europe, the steppe retreat left islands of ice-free terrain known as refugium, around which late glacial hunter-gatherer groups gathered, preserving pockets of genetic and cultural diversity. In between the coldest pulses lay interstadial's brief, warmer phases when glaciers receded and forests reclaimed lowlands. These windows of respite allowed tundra-adapted trees like birch and willow to colonize soils freed from ice. Saplings spread into sheltered river valleys, providing nuts, berries, and wood for tools and fires. Mammoths and horses moved aside as spruce and pine advanced, and hunters pivoted from megafauna to reindeer, elk, and smaller mammals. But these respites were fleeting. Climate oscillations repeated with near clockwork regularity, and species had to be as adaptable as the environment was variable. Throughout the Ice Age, rivers and lakes played crucial roles in sustaining life. Glacial meltwater fed braided rivers that wove across outwash plains. Seasonal floods deposited nutrient-rich silts that fostered new grass growth in spring. Periglacial lakes, formed by ice-dammed valleys, harbored fish and waterfowl, whose eggs provided vital protein. Floating mats of vegetation along thawing shorelines supported beavers and muskrats, whose lodges created complex wetlands. These waterways became lifelines, drawing herds and hunters alike to their shores year after year. As the Holocene dawned around 11,700 years ago, glaciers withdrew and landscapes warmed. Mammoth steppe gave way to birch and pine forests, and musk oxen retreated into high tundra. Many megafauna already pressured by human hunting found shrinking habitats and fragmented herds. Woolly mammoths dwindled to isolated populations on remote Arctic islands, Wrangel and St. Paul, before vanishing entirely around 4,000 years ago. Saber-toothed cats, giant deer, and dire wolves fell to extinction in quick succession. Their absence rippled through ecosystems. Predators lost, scavengers dwindled, and seed dispersers vanished, altering vegetation patterns in ways still evident in pollen cores and genetic studies. Yet other species persisted by shifting strategies. Reindeer adapted to woodland life, moose thrived on new aquatic plants, and beavers expanded into temperate wetlands, engineering ponds that became cradles for amphibians and waterfowl. Brown bears followed salmon runs upriver, mirroring glacial meltwater pulses. Tribal cultures, too, transformed. Mesolithic communities in Europe adopted complex fishing methods. Farming villages in the Near East emerged on fertile alluvial plains, and nomadic herders tracked seasonal pastures across newly wooded steppes. In modern reflections on the Ice Age, we glimpse a period of extremes that forged resilience in life's tapestry. The glaciers that once grounded continents now lie in distant memory shrinking remnants, clinging to polar peaks. Yet their legacy endures in glacial valleys, in the genetic codes of cold-adapted species, and in the cultural rhythms of indigenous peoples whose ancestors carved survival strategies amid ice and wind. The woolly mammoth's bones, scattered across plains from the Yukon to Siberia, remind us of a time when giants ruled frozen realms. The caves that sheltered hunter-gatherers echo with art depicting mammoth hunts and woolly rhino charges, stories written in soot and ochre on stone walls. And as we consider the world warmed and reshaped by humanity's own hand, the Ice Age arrives in memory more than in living breath. Yet in every thawing permafrost and retreating glacier, we see the outlines of that ancient cold, a reminder that Earth's climate remains a force beyond any single lifetime. The struggles of survival against ice and hunger, of herd and spear, continue to resonate in our DNA and cultural heritage. In the hush of melting snow and the pulse of returning streams, we hear the echoes of a world that endured ice's unrelenting embrace and of life's determination to find warmth, to adapt, and to press forward into new seasons still waiting beyond the horizon. Dawn light filters through acacia branches as a small group of hominins moves across the savanna's edge. Their bodies stand upright, ribs and pelvis shaped for bipedal strides that carry them between clusters of termite mounds and shady tree groves. These earliest ancestors members of the genus Australopithecus emerged around 4 million years ago in East Africa's mosaic of woodland and grassland. They balanced hand axes and digging sticks in their grasping hands, foraging tubers and fallen fruit, pausing to scan the horizon for predators. In that half-light between forest and plain, hominins rehearsed the choreography of survival. Upright alertness, careful use of tools, and a growing reliance on group cooperation that set them apart from every other creature roaming the dawn-lit landscape. Over generations, Australopithecus afarensis learned to exploit two worlds at once. By day they descended to open ground to gather roots and nuts. By night they climbed into trees to avoid prowling cats. In fossilized footprints at Letoli, Tanzania, we see their gait, heavy hips swinging forward on long toes. Their jaws remain strong for chewing fibrous plants, yet their brains, though still small, show hints of neural expansion. Within their social bands, older females taught younger members to identify edible plants and avoid hidden crevasses. Every evening, dusk fires were mere embers of future mastery. But even without permanent hearths, Australopithecus recognized the value of returning to familiar roots, of marking territory with communal trails, and of learning from each sunrise's lessons. As climates shifted in the Pliocene toward cooler, drier trends, woodlands contracted and grasslands spread. In response, hominins evolved new strategies. By 2.4 million years ago, Homo habilis appeared, its larger brain case reflecting an increased capacity for problem-solving. Called handy man, this species crafted Oldowan tools, stone flakes napped from river cobbles, sharp enough to slice meat from bones and to split marrow-rich shafts. At Olduvai Gorge, archaeologists unearthed butchered antelope bones, revealing that habilines scavenged carcasses left by lions, then carried prized cuts back to safe rock shelters. This scavenging required planning, anticipating predator patterns, timing approaches at dawn or dusk, and coordinating group movements to withdraw before danger closed in. Inside shallow caves and rock overhangs, early homos organized simple camps. Sparks struck from flint initiated small fires that warded off hyenas and illuminated nightly gatherings. Around these flickering flames, individuals cleaned tools and shared pieces of meat. The glow revealed finger traces on stone, the outline of napped edges, and the first flickers of social bonding through storytelling in grunts and gestures. Fire's warmth extended activity into cooler hours and protected young ones when predators prowled beyond the light's edge. In turn, reliance on fire-shaped anatomy, shorter toes for efficient walking over long distances to collect firewood, and vocal cords that diversified calls into rudimentary proto-language. By 1.8 million years ago, Homo erectus upright human ventured beyond Africa into Eurasia's warmer zones. At Manisi in Georgia, hand-sized skulls with thick brows signal their presence in cool highlands. With their larger brains and more sophisticated Acheulean tools, hand axes shaped like teardrops, they hunted cooperatively, possibly driving game between rock ledges or enticing animals into natural traps. Clothing may have begun as simple skins draped for warmth, evolving into tailored garments pinned by bone holes. Fire was no longer an occasional convenience, but a critical lifeline, ignited in sheltered hollows and maintained through seasons to bake tubers, harden spear shafts, and offer refuge from cold nights. Erectus bands radiated along river valleys where water and food converged. At Shaokudian near Beijing, ash layers and charred bone fragments mark sustained occupation. These hominins stood over 1.5 meters tall, their bodies adapted for endurance running, narrow hips, long legs, and sweat glands that cooled the body under midday sun. Hunting strategies evolved from passive scavenging to active pursuit. Wooden spears darted into herds, driving antelope or boar toward awaiting hunters. Coordination and planning defined each hunt. Flanked drives to confuse prey, coordinated flanking to isolate stragglers, and signal calls to summon helpers. The landscape itself became a partner, with animal trails known intimately and waterholes memorized like maps. Meanwhile, in southern Europe and the Levant, Homo heidelbergensis cropped up around 700,000 years ago. Their robust skulls and larger brain volumes hinted at advanced cognition. At Mérignac in France, wooden spears preserved in waterlogged sediment show long-range hunting. Thrusting implements 6 feet in length could dispatch large deer with single drives. Hunting camps near riverbanks bristled with flint points and antler tools, each carved and sharpened by practiced hands. Shared kills were butchered collectively, hide racks erected, and cooking spots arranged by social hierarchy. The surviving elderly, those past their prime for hunting, passed on knowledge of seasonality and animal behavior to younger generations, forging traditions that would echo through Ice Age cave art. As northern latitudes cooled, human groups adapted. At Boxgrove in England, butchered horse bones at 500,000 years ago coincide with climate interglacial. Erectus descendants huddled beneath chalk overhangs, their faces hidden from biting winds. Their stone toolkits diversified, flakes for scraping hides, scrapers for woodworking, and burins for engraving bone. Hearthstones show repeated fire use, and hearth-centered camps reflect social learning spaces. When glacial advances forced retreats to southern refuges, populations fragmented into isolated communities, each fostering unique tool styles and hunting preferences, a pattern that would later inform our species' cultural diversity. By 300,000 years ago, Homo sapiens arose in Africa amid grasswood mosaics. Their brains surpassed earlier hominins in complexity, enabling richer symbolic thought. Stone tool industries, the Middle Stone Age saw blades removed from prepared cores, producing standards of uniformity ideal for hafting onto wooden shafts. At Pinnacle Point in South Africa, remains of shellfish, fish, and bird eggs in backed blade sites indicate broad-spectrum foraging. Coastal resources supplemented savanna game. Shell beads and ochre fragments imply emerging aesthetic sense and personal ornamentation. Language likely blossomed, enabling precise communication about tool production, seasonal cycles, and social rituals. Modern humans ventured into Eurasia around 70,000 years ago. Crossing the Red Sea's narrow straits, small groups navigated by night sky and coastal landmarks. Along South Asia's river plains, rock shelter art adorned walls with red ochre dots and hand stencils early signatures of presence. Spears crafted in composite-formed stone tip, bone foreshaft, wooden shaft tested accuracy in drives of medium-sized game, deer, boar, and waterbuck. When macrofauna declined in colder zones, humans shifted to small, fast game, birds netted in reed traps, and roots excavated with sharpened digging sticks. Flexibility in diet and toolkits underpinned expansion into diverse ecologies. In Europe, Homo sapiens encountered Neanderthals, robust cousins adapted to Ice Age conditions. Though competition existed, evidence shows exchanges. Levallois flake technology crosses species lines, and Neanderthal DNA persists in humans outside Africa. Shared caves Grotte Mandarin in France, between 56,000 and 51,000 years ago, reveal alternating occupations, each leaving distinct tool assemblages. The mosaic of contact and replacement influenced innovation. Humans adopted Neanderthal cold-adapted hunting strategies, while Neanderthals assimilated refined blade production. Yet, as climate oscillated, Neanderthals dwindled, possibly due to smaller populations, reduced genetic diversity, or inability to outcompete the more versatile Homo sapiens. By the last glacial maximum at 21,000 years ago, humans carved survival in ice-swept Europe and northern Asia. Clothing evolved into tailored parkas sewn from hide strips, and footwear shaped as moccasins, insulating feet on snow. Fish hooks fashioned from bone signals, fishing beneath ice-free water channels. Sledges and rope binders enabled transport of heavy resources across tundra. Social networks stretched between refugia, evidenced by shared genetic markers thousands of kilometers apart. Language fostered broader alliances, ensuring gene flow and cultural continuity in isolated pockets. As ice retreated, humans pioneered new frontiers. Coastal migrants followed Pacific Rim into Australia 65,000 years ago, using ocean-going rafts or walking across submerged continental shelves. They exploited shellfish and rainforest fauna, adapting to monsoonal climates. Rapid innovation followed: ground axes for woodland clearing, fish traps in river estuaries, and seed grinding stones. In the Americas, Bering Land Bridge settlers moved into mammoth steppe and lush interglacial woodlands, founding Paleo-Indian cultures around 15,000 years ago. Clovis technology projectile points, fluted for hafting marks, a hunting revolution for big game procurement across vast territories. Throughout these millennia, early humans wove lives in synchrony with environment. Settlement patterns tracked resource pulses. Seasonally mobile camps by salmon rivers, winter shelters in rock alcoves, summer foraging in alpine meadows. Plant domestication commenced in the Fertile Crescent circa 12,000 years ago, as hunter-gatherers transitioned to farming wheat and barley. Animal domestication followed goats in Zagros foothills, pigs in East Asia molding hominin societies from egalitarian bands to villages with social stratification. Tools refined into pottery and weaving looms, permanent dwellings replacing temporary shelters. Storytelling blossomed into myths, songs, and art. Lascaux's cave paintings firelight, illuminating bison and horses, painted 15 millennia ago, capture human awe of prey and communal memory. In Venus figurines, exaggerations of fertility signal symbolic thought. Music emerged. Bone flutes at 40,000 years ago delivered haunting melodies to Paleolithic gatherings. Rituals crystallized around burial practices. Graves at Kafsia in Israel bear red ochre stains, suggesting belief in an afterlife. These cultural layers reflect a species reshaping both biology and imagination. The journey from Australopithecus to agricultural societies spans 4 million years of persistent adaptation. Each environmental shift, woodland to savanna, glacial cold to interglacial warmth, coastal inundation to desert expansion, prompted new inventions. Stone tools to bronze blades, shelters from caves to mud brick houses. Social structures scaled from small foraging bands to chiefdoms and early states. Language evolved from grunts to complex syntax, enabling transmission of abstract knowledge across generations. In the soft glow of dawn, humanity's ancestors once scanned horizons for predators. Today, we scan climate projections and ecological crises. Our species' story is one of ingenuity born in twilight forests and ice-carved plains, of cooperation forged around hearth fires, of creativity etched in cave walls. As we confront new frontiers, space exploration, genetic engineering, ecological stewardship, we carry lessons from those early hominins who harnessed stone, fire, and social bonds to carve a path through ever-changing worlds. And still, with each sunrise, we step onto landscapes alive with memory of footprints pressed into ash and ice, ever reminding us that survival depends on adaptation, cooperation, and an unending curiosity about the world we inhabit. A soft breeze stirs the tall grass, where once an unbroken forest stood, reminding us that human footprints have long reached deeper than any other species flooring the earth. In the waning millennia of the Pleistocene, small bands of Homo sapiens first began to clear woodlands for camps and fires. What began as gathering tinder for hearths became systematic felling of trees, open fields for nuts, tubers, and wild grains. Where once apex predators and megaherbivores shaped the land, early farmers took up the mantle, selecting plants for larger seeds and easier harvests, inadvertently initiating a transformation that no other creature had ever staged. In the Fertile Crescent, perhaps 5,000 years before present, the first known cereal grains were domesticated. Emmer wheat and barley, once brittle, rachized, and meant to scatter seed on the wind, were bred into forms with tough stalks holding plump kernels. But these early gains came at the expense of forests. Oaks and pistachios retreated as herds of goats and sheep browsed saplings. Fields of golden grain replaced the shaded understory. Soil that had weathered millennia of leaf-litter humus now faced annual tillage, exposing it to wind and water erosion in cycles that would accelerate the turnover of topsoil far beyond natural renewal rates. As plowshares carved the earth, irrigation channels followed. In Mesopotamia's alluvial plains, canals diverted Euphrates floods into rice and date palm groves, feeding growing cities like Uruk and Babylon. Levees confined rivers, choking off silt that once replenished floodplain soils downstream. Salt-laden water rose in the buried layers, turning once fertile fields into swaths of alkaline desert. Farmers responded by cutting new channels and planting salt-tolerant date palms. But the cover crop mosaic that once held the land in balance was broken, and only millennia of human maintenance kept these landscapes productive. Across the globe in the Yellow River Basin, Chinese dynasties built elaborate canal and terraced networks to irrigate rice paddies. Engineers bent nature to their will, sculpting mountainsides into staircases of flooded fields that fed the Han Empire's millions. Yet every harvest season, patchwork slurries of sediment and pesticides flowed downstream, smothering confluence habitats and altering fish migrations. Aquatic species adapted to slow currents now faced turbid rushes that reshaped streambeds, forcing communities to relocate fish traps and rethink seasonal calendars. With the rise of cities came concentrated waste streams. Streets in ancient Rome, once lined with stone aqueducts supplying fresh water, also funneled sewage into the Tiber. Public latrines flushed with running water, a marvel of engineering, nevertheless transported pathogens and organic loads that depleted oxygen in river stretches. Urban sprawl consumed nearby woodlands for building timber and fuel, creating a ring of deforestation around population centers. As Rome's empire expanded, iron smelting furnaces multiplied, requiring ever more charcoal, further stripping hillsides until soil erosion silted harbor channels and crippled trade. Metallurgy's hunger for ore transformed mountain landscapes. Bronze Age miners tunneled into hillsides across Anatolia and the Alps, dumping waste rock into valleys that clogged streams and raised riverbeds by meters. Copper and tin smelting released sulfurous fumes, acidifying precipitation downwind and altering forest growth patterns. By the Iron Age, Scandinavia's valleys bore scars of peat mining for iron bloomery charcoal, shifting bog ecosystems toward drier heathlands and reducing peat's capacity to sequester carbon, a silent, centuries-long feedback on atmospheric composition. When Phoenician mariners first carried olive groves to Iberia, they They unwittingly illustrated the power of human-mediated biotic exchange. Olive cuttings rooted on rocky hillsides, transforming wild woodlands into orchards that thrived on Mediterranean slopes for millennia. In the Pacific, Polynesian voyagers transported breadfruit, coconut, and banana across thousands of kilometers, reshaping island ecologies. Endemic species, flightless birds, specialized insects, fell victim to introduced rodents and pigs. By the time Europeans arrived centuries later, New Zealand's moa were extinct, and Hawaii's forests were irrevocably changed by mango and guava thickets. Medieval Europe saw its own transformation. Shipbuilders in Venice felled vast cypresses from the Apennines for naval timbers. Charcoal pits proliferated, fueling ironworks that produced armor and swords. Feudal agrarian practices extended arable land at the expense of ancient beech oak woodlands, replacing them with rye fields and grazing pastures. The resulting patchwork sustained growing populations, but eliminated deep forest refugia for wildlife, reducing biodiversity long before scientific taxonomy would name the losses. The dawn of the Columbian Exchange in the 15th century threw ecological doors wide open. European settlers in the Americas cleared prairies for wheat and barley, plowing bison ranges into farmland. In Brazil, sugarcane first, planted on São Vicente, in 1532 spread to floodplains, guarded by enslaved labor. Vast sugar estates drained wetlands, channeling runoff that fueled downstream palmate cultivations while creating hypoxic dead zones in Brazilian estuaries. Cattle introduced from Iberia bred feral herds that compete today with native species like jaguars and giant anteaters. Across both hemispheres, guns, germs, and steel redrew human demographics and ecological patterns. Smallpox decimated indigenous populations in the Americas, leaving field systems untended and forests to reclaim abandoned villages. Yet at the same time, European livestock cows, pigs, horses stamped the soil, introducing hoof-compacted pastureland where wild herbivores once roamed. Grass species like Timothy and Kentucky bluegrass arrived on ship hulls and in ballast, forming lawns and pastures that altered soil microbiomes and hydrology from New England to the Pampas. Then came the Industrial Revolution, the moment when human engines began to outpace nature's rhythms. River valleys once shaped by grazing and flood pulses saw coal-fired steam engines belching soot into the sky. Factories clustered in North England, the Ruhr, and New England's Blackstone Valley, their smokestacks leaving acid rain that bleached forests downwind. Railroads fanned out like iron veins, fragmenting habitats while carrying clams, earthworms, and plant seeds in cargo holds emergent invasives that colonized cleared rights of way. As coal yielded to oil, human extraction reached new depths. Open-pit mining in Appalachia removed entire mountaintops, burying headwater streams under rubble and releasing heavy metals into fragile headwaters. Tar sands operations in Alberta leveled boreal forests for refining operations that tainted wetlands with organic pollutants. Offshore drilling platforms anchored in continental shelves churned seafloor sediments and leaked hydrocarbons, smothering coral reefs and mangrove nurseries. In agriculture, the Haber-Bosch revolution exponentially increased reactive nitrogen in terrestrial systems. Synthetic fertilizers lubricated yield surges, feeding billions, yet unleashed massive nutrient runoffs. The Gulf of Mexico's dead zone, over 22,000 square kilometers, now forms each summer as fertilizer. Laden rivers feed algal blooms whose decay consumes oxygen, collapsing fish stocks and shellfish beds. Phosphorus mining adds to this load, further displacing natural nutrient cycles laid down over eons. Meanwhile, chemical industries synthesized persistent organic pollutants DET, PCBs, PFBs that spread globally in air and water, bioaccumulating in tissues of polar bears and migratory birds far from industrial centers. Microplastics, first observed in the 1970s, now pervade every corner of the oceans, rivers, and even the atmosphere, ingested by plankton that form the base of marine food webs. Humans have become stewards of a planetary garbage patch visible from space, its swirling currents mixing refuse from every continent. Urban sprawl advanced at unprecedented rates in the 20th century. Infrastructure networks, roads, pipelines, power lines cut wildlife corridors into segments too small to sustain wide-ranging species. Cities now occupy more than 3% of terrestrial land, but their ecological footprints extend far beyond. Concrete runoff changes local river chemistry. Nighttime lighting disrupts insect navigation and bird migrations. Aerial noise from aircraft and highways alters animal communication over dozens of kilometers. Overfishing, too, recast oceanic food webs. Industrial trawlers harvest deep-sea fishes, once sheltered by depth and cold. Bycatch of sharks and rays exceeds intentional catch in some fleets, triggering declines in top predators that cascade through marine ecosystems. Coral reefs, deprived of grazing fish, succumb to algal overgrowth. Mangroves' natural coastal buffers are cleared for shrimp farms, further weakening coastlines against storm surges. By the early 21st century, human carbon emissions had raised atmospheric beyond 400 parts per million levels not seen in 3 million years. Global temperatures rose in lockstep, melting polar ice caps and thawing permafrost. Ancient carbon liberated from tundra soils enters streams as dissolved organic carbon, fueling bacterial blooms that release methane. Changing precipitation patterns dry once humid rainforests and intensify monsoons, accelerating erosion and weather extremes. The climatic backdrop against which life evolved for millennia now slides on a new trajectory, uncharted and swift. Human-shaped ecosystems now sport novel plant and animal assemblages. Kudzu blankets southern U.S. hillsides. Fire ants dominate disturbed soils in many tropical zones. Zebra mussels clog freshwater intakes in Europe and North America. We call these novel ecosystems, combinations of species that never coexisted before human intervention. They flourish in urban wastelands, roadside verges, and abandoned industrial sites, rewriting ecological rules born in pre-industrial ages. The weight of these changes has earned our epoch a new name, the Anthropocene. Stratigraphers now debate its formal recognition in the geological record. But regardless of formal ratification, human fingerprints mark every sedimentary layer laid since the mid-20th century. Radionuclide spikes from nuclear tests, microplastic shards, black carbon, and a surge of metal pollutants. Future geologists will read these layers as the unmistakable signature of the first species to reshape Earth on a planetary scale. Yet amid this unprecedented transformation, we glimpse paths of restoration. Rewilding projects in Europe reintroduce bison and beavers to floodplains, reviving wetland dynamics that sequester carbon and rebuild biodiversity. Grazing proxies circulate in North America to mimic Pleistocene megafauna's ecological functions, restoring grasslands once kept healthy by mastodon herds. Urban greening initiatives plant canopy trees to cool heat islands and capture stormwater, reknitting ecological threads in human heartlands. As humanity reckons with its ecological footprint, new technologies offer tools for stewardship: satellite monitoring of deforestation, gene drives to control invasive species, and carbon capture to draw down the greenhouse gases we once unleashed. Indigenous land management practices rotational burning, sacred groves, communal fisheries offer time-tested wisdom that respects the balance between use and renewal. Combining cutting-edge science with ancestral knowledge could guide us toward a new equilibrium. But human agency carries weighty responsibility. The scale and rate of ecosystem change must slow if long-term resilience is to recover. Policies that set aside protected areas, reduce emissions, and invest in ecological infrastructure, green corridors, restored wetlands, regenerative agriculture, can shift trajectories from damage to healing. The challenge is nothing less than redefining humanity's role from dominant engineer to mindful guardian of planetary health. In the final measure, human activity has indeed ushered in the end of one geological era and the dawn of another. We stand at a crossroads between legacy and possibility. The scars we leave, deforested plains, acidified oceans, extinct lineages form one story. Yet the seeds of restoration re-wilded valleys, thriving wetlands, reconnected rivers hold another. The future chapter depends on whether we value the ecologies we have reshaped enough to steward them, with the same determination that once unleashed change. In doing so, we might yet craft an ending worthy of a species whose arrival on the planetary stage has altered life in ways no species had before. Life on Earth today wears the mantle of the Cenozoic like a garment woven from millions of years of change. Every mountain range that pierces the sky, every ocean current that pulses heat around the globe, every savanna that ripples in golden grasses, each carries a signature of that era's relentless transformations. It was in the Cenozoic that continents drifted into their present positions, that climates swung between greenhouse warmth and icehouse chills, and that life exploded into new forms. As dawn breaks over familiar landscapes, we find echoes of that deep epic in every stone, every living creature, and every breath of wind that stirs our world. The very outlines of the continents reflect Cenozoic wanderings. India's northward voyage against Eurasia lifted the Himalaya. The Andes rose as South America rode the Pacific's edge. Africa collided with Europe to sculpt the Mediterranean's basins. These tectonic encounters not only shaped topography, but redirected atmospheric currents, spawning monsoons in Asia and rain shadows across Central Asia. Today's climate's tropical rainforests in Sumatra, deserts in Iran, temperate forests in Europe are direct heirs to those collisions, as are the river networks that nourish civilizations from the Ganges to the Amazon. Mountains like the Rockies and Alps tell similar stories. Uplifted in waves through the Miocene and Pliocene, their uplands altered wind patterns and jet streams, creating distinct rainfall belts. Glacial carve marks on their flanks testify to ice ages born of high elevation snowfields. These peaks cradle unique ecosystems, alpine meadows, and montane cloud forests, whose biodiversity thrives on the gradients of altitude. Water released from snowmelt feeds floodplains that once hosted mammoths and now sustain rice paddies and wheat fields, binding human history to Cenozoic hydrology. Oceans, too, bear the signatures of that era. The opening of the Drake Passage let the Antarctic circumpolar current circle, unnoticed until ice sheets claimed Antarctica as plateaus. The rise of the Isthmus of Panama rewired tropical currents, fueling the Gulf Stream's warmth toward Europe. Today, as thermaline conveyor belt-shaping weather from Greenland, its fjords to the West African coast owes its path to seafloor spreading and continental collisions of the Cenozoic. Marine fisheries track plankton blooms steered by these currents, while coral reefs cluster where warm, nutrient-balanced waters remind us of ancient seaways. The spread of flowering plants during the Paleogene and Neogene established the forest and grassland biomes we know today. Early angiosperms found open niches, teaching insects, birds, and mammals to pollinate and disperse seeds in new dances of coevolution. Modern hardwood forests in eastern North America and Europe trace their lineages to those first warm, moist epochs, and the vast boreal spruce and pine woods reflect cooler interglacial pulses. In each leaf unfurling beneath today's sunlight, we glimpse the green legacy of Cenozoic innovation. Grasslands, too, emerged as a Cenozoic hallmark when CO levels fell and seasonal rains grew sharper. C4 grasses conquered open landscapes, giving rise to savannas and prairies that favor high-crowned teeth and swift hooves. Zebras, buffaloes, bison, and horses icons of these realms are direct descendants of Miocene browsers. Their grazing patterns maintain nutrient cycles in soils that support livelihoods from Eurasian steppe nomads to American ranchers. With each blade bitten and seed dispersed, grassland animals perpetuate the Cenozoic's gift of open country ecosystems. Mammals flourished as no other vertebrates had, from shrew-like Paleocene pioneers to the megafauna of the Pleistocene. Yet beyond their grandeur, modern mammal diversity, from bats that pollinate to whales that filter, owes its roots to the adaptive radiations of that era. Marsupials in Australia, xenothrans in South America, elephants in Africa, and rodents worldwide all trace branches to Cenozoic split events. Their evolutionary experiments in body size, diet, and sociality set enduring patterns in predator-prey dynamics, dispersal abilities, and ecosystem engineering that we still observe today. Birds seized the skies in the early Cenozoic, giving rise to the major avian lineages we now admire. From the ratites roaming downed lands to the songbirds warbling at dawn, modern birds recall ancestors that conquered niches left by extinct pterosaurs and non-avian dinosaurs. Migratory routes linked breeding and wintering grounds, patterns established when continents reconfigured. Raptors that ride thermals, hummingbirds that hover at flowers, and penguins that patrol frigid coasts all carry anatomical and behavioral legacies coded deep in their genes from a time when feathers first learned the language of flight. Marine life rebounded spectacularly, too. Coral reefs that had vanished in the late Cretaceous reasserted themselves in the warm seas of the Eocene, earthing the reef communities that now shelter a quarter of all marine species. The advent of cetaceans, the whales that breach in modern oceans, originated in land, dwelling ancestors that entered the water during the Eocene's thermal pulses. Today's whale migrations from polar feeding grounds to tropical breeding lagoons echo the rhythmic pulses of Cenozoic climate transitions, binding ocean giants to the ebb and flow of Earth's thermostat. Climate itself remains stamped with the Cenozoic's oscillations. The icehouse world that emerged in the Oligocene still cycles through glacial-interglacial episodes paced by orbital shifts shaped in those eons. Ice core records of atmospheric CO, dust, and temperature carry signatures of these rhythms, teaching us that Earth's climate is a responsive system, sensitive to greenhouse levels and continental arrangements. Modern warming, abrupt by geological standards, finds its counterpoint in Cenozoic hyperthermals that display both devastation and resilience, offering clues to how ecosystems might adapt or collapse under rapid change. Soil landscapes reflect the slow handiwork of icing and deglaciation. Loess plains in China and the American Midwest formed from glacial dust blown in cold winds, providing some of Earth's most fertile agricultural lands. Podzols in boreal forests and terra rosa in Mediterranean woodlands were sculpted by weathering processes begun in the Eocene's warm, humid chapters. Each spoonful of dirt underlies complex microbial communities that decompose organic matter, a process honed over tens of millions of years and essential for carbon storage, nutrient cycling, and plant growth. The carbon cycle itself bears the Cenozoic's deep marquee. Vast coal seams in Patagonia and Antarctica, oil and gas reserves in the Middle East and North Sea, and shale deposits around the world originated when ancient forests and planktonic blooms sequestered carbon beneath sediments. As we extract these fossil fuels and release carbon back into the atmosphere, we disrupt the Cenozoic calibrated balance of greenhouse gases that regulated Earth's temperature for millions of years. The ensuing climate change is a stark testament to the potency of those buried legacies and to the care with which we must handle them. Biodiversity patterns trace back to Cenozoic subtleties. Tropical hotspots Madagascar, the Amazon basin, Southeast Asian archipelagos flourish, where stable climates and complex landscapes allowed lineages to persist and radiate. Conversely, temperate regions show fewer endemic species, reflecting harsher glacial cycles that prune diversity. Conservation priorities today lean heavily on these hotspots, recognizing that their living fabric is woven from deep time and that protecting them safeguards the engine of evolution spins onward into the future. Human evolution unfolded in the final chapters of the Cenozoic. Its stages from Australopithecus to Homo sapiens played out against the backdrop of shifting forests, open savannas, and cooling climates. Our bipedal gait, tool use, and social structures were forged in environments molded by Cenozoic tectonics and climate oscillations. As modern humans now reshape the planet through agriculture, industry, and urbanization, we confront the paradox of being both a product of that era's legacies and their greatest challengers, wielding the power to heal or harm. The geological record remains our memory bank of that age. From the first flush of Paleocene pollen to the terminal Pleistocene extinction horizons. In deep-sea cores and cave deposits, isotopic ratios of oxygen and carbon recount temperature swings and vegetation shifts. Fossil footprints in ash layers echo the steps of extinct giants, and amber-intuned insects whisper tales of forest canopies long returned to Earth. Each discovery reshapes our understanding of how life adapts to planetary scale forces. Culturally, the Cenozoic inspires curiosity, art, and science. Dinosaurs may steal headlines, but the age of mammals provides the real roots of our planet's modern feel. The mammals in our backyards, the forests we hike through, the herds we graze and hunt. Fossils of early horses grace museum exhibits. Skeletons of giant ground sloths animate children's wonder. Skeletons of saber-toothed cats remind us that Ice Age predators once thundered where we now live. These encounters with deep time foster humility and awe, reminding us of our brief tenure in Earth's grand saga. Today's ecosystems are living mosaics built on Cenozoic foundations. National parks preserve vestiges of mammoth steppe and ancient rainforest. Marine reserves safeguard coral reefs that trace their origins to Eocene tropics. Seed banks protect crop wild relatives that co-evolved with grasses in the late Miocene. Restoration ecology often seeks to revive processes like beaver dam building and bison wallows that were integral to Cenozoic landscapes, but lost to Pleistocene extinctions and human expansion. In so doing, we acknowledge that true stewardship must engage with those ancient dynamics. As the planet warms beyond Holocene stability, we look to Cenozoic precedents. During the mid-Miocene climatic optimum, forests climbed to polar latitudes. During the Eocene-Oligocene transition, Earth moved into an icehouse state. These analogs guide climate models and ecological forecasts, though magnitudes differ. They caution that ecosystems can adapt across thresholds, but also that tipping points, like the opening of the Drake Passage, can lock in new climate regimes. Understanding these deep lessons equips us to navigate a future of unprecedented change. Ultimately, the Cenozoic's legacies are etched in stone, churned in soil, and sung by living creatures. From the towering mammoth fossils in permafrost to the DNA of tropical orchids, the echoes of that age reverberate through the living world. They remind us that Earth is a dynamic stage, its actors from plankton to primates shaped by shifting land masses, fluctuating climates, and evolutionary innovation. And as we step into the next chapter, we carry forward those legacies, entrusted with the care of an Earth still in the making. In honoring them, we ensure that the pulse of the Cenozoic continues to beat in ecosystems that sustain us and inspire the generations yet to come.